Cloud computing has become quite a buzzword these days. It evolved from a personal cloud storage to organizations moving their entire data to the cloud ecosystem. Now, we can obviously see an acceleration in the adoption of cloud computing services every year, a trend that doesn't seem to cease anytime soon. Hi, all. I welcome you to this crash course by Edureka, and today we are going to talk about one of the most popular cloud service provider, the Amazon Web Services. And what follows is hopefully everything you need to know to get started with AWS. But before we begin, let's look at our agenda for today. First of all, we're going to start by introducing you to AWS. Why is it required? What is it exactly? What are the advantages of using this sort of an architecture? So on and so forth. And then we're going to move on to security management in AWS, followed by which we are going to talk about AWS EC2, or the Elastic Compute Cloud, which is a web service that provides secure, resizable compute capacity in the cloud. It's designed to make web scale cloud computing easier for developers. Then we're going to move on to AWS S3, which is the only object storage service which maintains compliance programs, data protection directive, and helps you meet regulatory requirements. In the fifth module, we're going to talk about AWS Elastic Beanstalk, which is an orchestration service offered by Amazon Web Services for deploying apps. Moving on, we're going to talk about the Amazon Virtual Private Cloud, which lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. Then we shall discuss AWS Lambda, which is a service that lets you run your code without provisioning or managing servers. Our eighth module covers AWS Data Pipeline, which is a web service that you can use to automate the movement and transformation of data. Using Data Pipeline, you basically define data-driven workflows so that tasks can be dependent on the successful completion of previous tasks. And finally, the last module discusses CloudFormation in AWS, which is a service that helps you model and set up your Amazon Web Services resources so that you can spend less time managing these resources and more time focusing on your application that you run. With this, I come to the end of my agenda. Also, kindly take up this time to go ahead and subscribe to us. And don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about AWS EC2 S3 and Lambda, don't forget to check out our certification training, the link to which is given in the description box below. So without much ado, let's get started.
So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. The main agenda for today's session is we'll be discussing on what exactly is cloud platform, what are different service models available in cloud platform, why exactly we need cloud platforms, and what exactly is AWS as in Amazon Web Services, what are different domains available in AWS. All right. Now, first of all, let's understand the basics of cloud computing. Why exactly we need cloud computing? Now, for example, let's suppose we want to host a static website, right? Then we can now, when we are host a static website or any kind of application, both for web or mobile based, if we want to do support or deploy any particular application or website, then traditionally we had to buy a stack of servers, which will be holding up the entire data and which will be working as a main computation environment in which this application will be up and running. Then we have now once we buy those stack of servers, that means we have to invest a good amount of money in buying those stack of servers, right? And plus we have to invest in monitoring and maintenance of these servers on our own, right? That means here we have to take care of everything from buying the infrastructure to making sure that the entire infrastructure is updated in the current software department, and again making sure that these entire servers are up and running all the time. That means taking care of the entire deployment as well as making sure that the entire process is well monitored and the maintenance is also done from our own end, right? When we deploy something traditionally. And now the main drawback of this one is that this entire setup is expensive, because again here we have to, now when we are purchasing a stack of servers, obviously we need infrastructure in order to store those saves, store those physical servers as well, right? We need to make sure that we are investing a good amount of time and as well as money in making sure the entire system is up and running without facing any kind of issues, right? And depending upon the incoming traffic, suppose if we for some time we see the traffic getting increased and sometimes we see the traffic getting decreased as well, that means we need to have the entire application scaled up and scaled down, and traditionally we have to take care of these scaling up and scaling down manually, right? But again, these things are required when we deploy any particular application out there. And then after introduction of cloud computing, again, basically cloud computing is what? The entire infrastructure that is required to deploy the application remains as it is, right? Because again, it needs, any application needs to have a server, any application needs to have a database created, the entire servers also need to be maintained and everything needs to be done, right? That means there hasn't been any kind of I can say any kind of technologies being overwritten here. But again, the main setup of deployment has changed. That means instead of us taking care of everything, now everything is deployed on cloud. That means now today, if we have to deploy a website, then we can, now instead of buying the servers on our own, instead of taking care of the server deployments on our own, we can, and again, which will take almost a week in order to buy the servers, set up the entire operating system, set up the entire environment. Nowadays, if we want to launch a website, we can launch it within 15 minutes. We can launch it within 15 minutes if we want, right? That's how fast it has been, all thanks to cloud computing. Because here we already have the stack of servers already available, which we can simply hire, which we can subscribe to, and then we can simply get started on top of it, right? Whether we need a server, whether we need a storage service, whether we need any database services, or everything is now available to us as a solution, as a software itself, which we can subscribe, and again, that means we don't have to take care of any kind of manual implementation, maintenance, taking care of scalability. Everything is now taken care by the cloud computing platforms. And that's why these all services, like we have on cloud computing, we get the entire pile of, like the complete pile of services, including computation, database, storage, networking, everything, every kind of service that we need for the application deployments, right? And even for data analysis, for data science, for handling large volume of data, these all services are now available as a cloud service on these different platform providers here. All right. Now let's understand why exactly we need AWS here. Now AWS is basically the main cloud computing platform that is owned by Amazon. It is, again, it is one of the, we can say, the first most popular cloud computing platform that was ever deployed. So it started in 2006 and now it is having the biggest market share in the entire cloud computing providers. So AWS has the biggest market share, then followed by Microsoft Azure, and then followed by Google Cloud Platform, right? So that's the entire infrastructure of AWS here. So because AWS, as compared to other platforms, right? As compared to other platforms, AWS here offers 6 times better capacity. That means 6 times better performance as compared to all the platforms combined. All the platforms combined. And that's why AWS is the most popular cloud computing platform for every kind of team, for every team globally, right? And that's the market, and that's why this is the market share of AWS as compared to other players. Earlier it was even higher. Earlier it was more than 45%, but now it has been reduced to 31% because of multiple small players also coming up in the market here. But still, AWS still governs the highest amount of, or can say highest amount of market share for different cloud computing platforms and offering flexible pricing on top of it. All right. And now let's understand what exactly is AWS. So AWS is simply a cloud computing platform offered by Amazon, where AWS is a collection of more than 90 plus services. AWS is a collection of more than 90 plus services ranging from computation, databases, storage services, analytics, IoT, machine learning, data science, big data. So there are multiple data warehousing, there are multiple services available, right? And that we will be we will be looking at step by step as we move further in AWS domain platform. Now, let's explore the different domains available in AWS here. Now, AWS, as we had discussed, AWS is a collection of more than 90 plus services, right? So here we have multiple services on computation, on storage, databases, migration, networking, management tools, security and identity, compliance, and messaging, right? So there are multiple services here that we can use, that we can get started with.
Security management in AWS. So in this module, we'll be talking about IAM, which is identity and access management. We'll see how this can be implemented within your AWS account to manage your users and groups and their relevant permissions. We'll talk through various IAM components and also recognize the best practices of IAM. In the second part, we'll be talking about KMS, which is Key Management Service. So this is a service that helps you create and manage your encryption keys, which are subsequently used to encrypt your data on AWS. And lastly, we'll see how do we create billing alerts or cost management options that are available on AWS. So IAM is an abbreviation for Identity and Access Management, where it allows to manage your AWS users, groups, and roles and their access to AWS accounts and services. And IAM is a service which is global in nature, which effectively means that you have to create a user only once, and that user is applicable to across all these. So with IAM, you can provide access and access permissions to AWS resources such as EC2 or S3 or RDS service. For that matter, any AWS service that you consume. So there are three components that I'll be talking about. So you are familiar with Active Directory, which is largely used as a LDAP service in most of the organizations. The service is very similar to Active Directory, wherein you get to define users that need similar set of privileges. You would group them. And then additionally, Amazon has a custom implementation in form of roles. Let's talk about various components of IAM. So the first component is IAM user. So when you create an IAM user, by default, IAM user has a non-explicit deny for all the AWS services. So which means when you create a user, the user is not associated with any permissions at all. So you'll have to explicitly grant permissions to that particular user. And also you can specify which services that you want grant him access to. So let's say you want to grant permissions to a developer. So you might want to give him access only to EC2 service, wherein he only has the access to virtual servers or instances. So you may not want to give him access permissions to S3 storage service or probably network services that are available. So you can control the permissions at a very, very granular level. And IAM users receive unique access credentials, so we don't have to share them with other users. And user can have multiple IAM policies applied to them. So policy actually is a set of permissions that you specify. You specify permissions to the user by using policies. So policy is a document that formally states one or more permissions, and by default, an explicit deny always overrides an explicit allow. So there are pre-built policy templates for every service. So you have either full access or you have read-only access. And then at the account level, also you can specify whether a user can have a admin access or not. In case you're looking at building up a custom policy, so that option is also available within IAM, wherein you can specify, let's say you want to deny a user to terminate a specific resource. So you can actually specify that in the policy document. So essentially, policy is a document that formally states one or more permissions. So you need to write a JSON document. So Amazon also provides you access to a policy generator. So for those who are not familiar with JSON, the policy generator, you just have to, it's a web interface. You specify what permissions you want to apply or what permissions you want to deny against a specific AWS resource. The generator would actually generate a JSON template for you. Then we have IAM groups. So groups, it's actually collection of users having similar access needs. So for example, you have a project team that is working on a specific project and they need to have similar permissions. So you, rather than managing permissions at the individual level, it is always advised to manage the permissions at the group level. So that's the first advisory note from Amazon, that don't manage permission at the user level, but manage them at the group level. Lastly, we have IAM roles. So a role is something that another entity can assume, and in doing so, it requires the specific permissions defined to the role. So a very good example would be, let's say, wherein we were trying to create a bucket from the CLI interface. I had to pass on the access key and the secret access key, which is synonymous to username and password. So the second piece of advice from Amazon is never within your applications use the username and password to access a service. So how does the service actually access the target service, which is S3 in this case? So you can do it by virtue of roles. So I log into the portal, and since IAM is a global service, so it is not specific to any region, which means any user that I create, you can apply that user across all the region in which AWS operates. So for example, I was to work with EC2 service. So EC2 is a region specific service. So this would mean that the resources that I provision, in this case, Oregon region. So you have a root user at the top level. So root user is the one, it is actually the credentials that you supply when you create your AWS account. So that would typically be your email address and your password. So root user has unlimited privileges over your account. So it is highly recommended by AWS that never use your root user credentials or share them, because if they are compromised, any user who has the access can do whatever you want in your specific account. So root user is at the top level hierarchy and has unlimited privileges. So essentially it is the details that you have supplied, which is in the form of email and password during the account sign up process. This is actually the root user. The second type of users that you can create is admin users. So admin users, to an extent, they have permissions similar to as that of a root user, but with some limitation. So for example, let's say you want to change the support plan, or admins won't have the access to the billing console. So admins typically won't have these permissions. The admins will not have the ability to modify root user details, change the support plan, change or delete your payment options, or close an AWS account. So essentially, admin user can do whatever root user can do, and except for the limitations that we just discussed. Third type of the user, you have power users. So power users, they have similar permissions as that of admin. The only exception is that whatever limitations are applicable to admin would be applicable to power users as well. But another limitation is that they don't have access to IAM, which means they don't have the ability to manage users, groups, and their permissions. And the fourth type and the final type is generically referred to as IAM users. So IAM users, these are your custom users. So either you can make them admin or power. In case you decide not to give them admin or power users, you can specify custom permissions, and most of the times you will be using IAM users with custom policies. So four types: root, unlimited access permissions; admin, slightly lower than root user; and power, slightly less than admin; and lastly IAM. The user starts with no permission. It is up to, so once you log into your account, go to IAM, you see global out here. So services that are actually global. It's always a great idea to check the security status dashboard. And there are 5 items listed out here. First one is delete your root access keys. That is something that Amazon takes care of it right now. Earlier it was user responsibility. So that means you're not allowing the root user to connect either SDK or a CLI interface. So that is something that is being handled by Amazon. Earlier it was user's responsibility. The second aspect is activate MFA on root account. So MFA is multi-factor authentication, wherein you are introducing a second factor to authenticate against AWS. So if you recall, when I log into my AWS account, I supply username and password. That's simply because I've disabled MFA because I had to swap my phone. But usually for root user, admin users, or any priority users who have higher level of privileges, it is always advisable that you activate MFA on those. Then you have create individual IAM users. So if you have created IAM users in your account, so this would be green. Since you have very recently signed, this would be orange. Then use groups. So if you have created groups, this would again be green. And lastly, apply an IAM password policy. So this is very similar to password policy that you set up on Active Directories, wherein you set up password complexity requirements. So you can go to manage password policy. So you can specify the minimum length. So this is applicable at the account level. Any settings that you specify here would be applicable to all the users. So minimum password length should be 6. Then complexity requirements like uppercase, lowercase, number, alphanumeric, allow users to change their password, enable expiration. So this is again a great feature wherein almost every organization has an expiration policy like 30 days, 60 days, or 90 days, and you are forced to actually change passwords. So for the users who have access to AWS, you can actually force them to change their passwords depending upon your organization policy in terms of duration. Then prevent password reuse, again pretty similar. You cannot keep the previous 3 passwords as your current password. And then password admin expiration requires admin reset. So if the password has expired, in many times, many applications you will see request has actually go to the admin for setting that up. So we'll go to users, add user, give it a name. So I'm creating it by the name dev1. So assuming that he's part of the developer group and the users in the developer group would have similar access needs. So let's call it as dev1. And there are 2 types of access that you can grant to the user. The first one is programmatic access. So in this case, if you want to grant user the CLI access, or you want SDKs that he's working with to make API calls to AWS, you will have to generate a access key and a secret access key. So that is typically referred to as programmatic access. The second type of access is AWS Management Console access. So in this case, the user would actually be able to log on to AWS console. So let's say if you're creating an admin user, so then naturally you'll have to grant him console access as well. So if you are doing it for a developer, you can simply do away with programmatic access. So for now, we'll grant console access. We'll just supply a custom password. So I'm unchecking these, but as a good security measure, you should not change them. So I'm not adding the user to any group at this point of time, just to demonstrate that when a user starts with no permissions. This user would be able to do is simply log in to the AWS portal. That's about it. So for IAM users, they'll have to use a different user sign-in link. So the root user actually goes through the process that I do, which is aws.amazon.com. I actually sign in with root user credentials so that I have requisite access. So otherwise, all IAM users, that includes admin and power users and other IAM users, they will have to go through the IAM sign-in link. So you just go to customize and you can replace the account number with the name of your choice. So just grab this. So I'll be using a different browser because I'm already signed in as a root user in this account. I'm using Mozilla right now. So I'll say the username and then the password. So I've logged in as dev1 and let's see if I have access to any service. So it says you're not authorized. Any service that I actually go ahead and check, the user would not be having permissions. So it's access denied. So rather than applying permissions at the user level, so what I'll do is I'll go ahead and create a group and I'll be assigning permissions at the group level rather than at the user level. So the impact would be the same. So now we have an option to attach the policy. So policy, what we said was it's set of permissions that we're going to apply to this specific group that we are creating. So we can do it during the group creation process, or else we can always go back and then attach a policy to the group. So as you see, we have admin access. So this is admin access at the account level. Then you have power user access. So again, this is applicable at the account level. And for rest of the services, if you see, so for example, EC2. So in this case, you will have EC2 full access or EC2 read-only access. So we're looking at 2 extremes. Either the default templates can grant you full access permissions if you're talking at a specific service level, or read-only permissions. So if you want to do something in between, you'll have to create a custom policy. And for the users, if you want to make them admin power users, we can always do that. So what I'll do is I'll grant the EC2 full access to this user, this group rather. So I'll add that user to this particular group. So if I was to take a look at this user, it would clearly indicate what policy is applied to this user and from where it is inheriting that policy. So first check, we have granted him EC2 access. So now the user is able to access the EC2 service. So let's try with another service. The user should not have the access. So this is the correct behavior. Also, if I was to switch over to some other region, the user would still have the access to EC2 because we haven't put any restrictions at this point of time. But for rest of the services, again, the user would see the same impact. So I'll come back to the root user browser window. So what I'll do is I'll create another group, let's say project leads. So for project leads, let's say we are granting access to S3 service. So we're giving him S3 full access. So there are no users to it. So we'll add the user to it. So at the group level, you can see the permissions using the permissions tab. And now if you want to check that dev is part of two groups at this point of time, and you will see in the permissions tab what all permissions that the user is inheriting. So now the user has full access to EC2 and S3. And that too is inheriting it from two different groups. So now the user has access to S3 service as well. So if the user is inheriting permissions from multiple groups, the overall impact would be cumulative, sum total of all the permissions that is being inherited. So I'll talk about an exception also, wherein let's say in one group, the user was specified access to a service, and in some other group, the user was denied access to that service. So whenever there will be a conflict, a deny would always override an allow. So let's say if this user was to leave the organization. So one way is to manually go and delete the user. So many times you need the user account still active for a variety of reasons. You simply want that the user should not be able to do anything just in case. So I do have a deny all group and I've already specified a deny all policy. So in this case, I'm denying the access user to any service. So now the user is inheriting the permissions from three groups, and the third one actually denies the access to any service. So even though it has full access to EC2 and S3, the deny would actually supersede all the allows. So in case of conflict, a deny would always supersede explicit allow. So this is true for all the regions. So you can just flip around the regions and see the impact. The impact will be the same. So one takeaway here is the moment I change the permissions, the results are immediate. So there is no lag. You would see scenario-based questions wherein you change the permissions. So what would happen? So the impact would be immediate. So if you are granting access, the access would be granted on immediate basis. So as long as there is an allow, the resultant permissions would be cumulative. If there is a deny or a conflict, deny would always supersede. So I've already created a admin group, so I can actually go ahead and deattach and let's attach it again. So I'm using the pre-built template administrative access. So any user who becomes a part of this group now will have admin level privileges. So dev1 is now part of admin group. So let's go back to the dev1 browser window. So now the user has access to all the services. We also said that this admin user has some limitations, predominantly in form of changing the support plan, closing the account, access to billing dashboard. So let's see if this user has access to the billing dashboard or not. So by default behavior is that the access is denied. So if I was to actually go ahead and check it with root user credentials, so I'm able to access it. Likewise, you can set up a power user group, simply attach a power user access. So now this user is part of power user. So effectively has all the permissions that admin had, except, this would still be applicable because admins did not have this privilege. In addition, this user would not have access to IAM, which means this users in the power group won't have the ability to manage users and groups or their permissions. So we have the desired behavior. So in order to activate MFA, so you could either use a software application or a hardware token. So if you want to use a virtual MFA, so based on the platform, if you have Android, iPhone, or Windows Phone, you could either use Google Authenticator, Auth 2 factor authentication. So any one of these. So most commonly used is Google Authenticator. So you can just simply go ahead and download it from the Play Store or App Store. Else, if you decide to use a hardware token, so hardware token would look something like this. So the process to set up MFA is pretty straightforward. So let's say we want to set up MFA for Dev1. Go to Security Credentials tab And then you have an option assigned MFA device. Just say manage, specify what type of MFA you want to use. So we are using virtual MFA, and using your smartphone, scan the QR code. And there's another step, subsequent step. And doing that, it would Google Authenticator would become your second factor authentication. So let's try this out on the root user. So for the root user, in your case, it would be the account number. Just go to My Security Credentials and activate MFA. So I already have a Google Authenticator with me. So I'm scanning this. So on the Google Authenticator application, I get two codes. I'll have to punch in that. So wait for 30 seconds. It would generate the second set as well. Let's say Devon already member of Power users. So let's see, we are logged in. Yeah, we are logged in. So this user will still have access to all the services. So for the purposes of demo, I'm just taking out two services, EC2 and S3. So this user has access to all these services, which is very similar to admin. So now admin did not have access to the billing console. So this user will also not have access to the billing console. Also, power users don't have access to IAM. So IAM, we know it is used to manage your users. You can create them, grant permissions to them. So you don't actually have access to the IAM service per se. So now what I'll do is I'll remove this user from the power user group. So now this user is now a member of admin. So earlier he was member of power. So now this user should have access to IAM, which means as an admin, you have the ability to create users, manage them, grant specific permissions the way you like. Let's say we want to build custom policies. Rather than granting access as a whole to a service, we want to restrict to some specific set of permissions. So in the first part of the demo, what I'll do is I'll create an admin policy template just to make you familiar with how the policy template looks like, and we'll take it forward wherein we'll restrict this user from accessing. We'll grant him EC2 access, but only to a specific region, and then enabling only specific set of actions. So we have a policy generator available. So we'll just use that to create our JSON template. Select the type of policy that we want to create. So in this case, we are creating a IAM policy. And the effect, this is essentially stating whether we want to allow or deny the access. So in this case, we're saying allow the access. And in the drop down that you see is set up for all the AWS services that are available. So I'll check all the services since I'm creating an admin policy. And I'll just simply hit add statement and then generate policy. So this is how your policy statement would look like. SID is more like a description, optional. Action, or we'll start with effect. In this case, we have said allow, and actions by default. We said allow to all the services, and action is every action applicable to each service. So this is your admin policy. If you were to actually compare it with the admin template, this is what we have. So you can create your own policies the way you like. So now let's create a custom policy now, wherein let's say whosoever this policy is applied. So we are applying it to the developer group, and they'll have access to EC2 service, and that would be specific only to a one region. So let's say Oregon. So in this case, we'll select EC2. Then within EC2, these are the set of actions that you could actually perform. So to keep it simple at this point of time, I'll select all the actions, which is equivalent to EC2 full access. ARN is Amazon resource name, wherein every resource that you create on Amazon generates a ARN. So you can actually specify which specific resource you want to control access to. So let's give it asterisk out here, any resource within EC2. And now I'm adding a condition. So these are the operators that I can use, say string like, and I'll use region since this is what we want to achieve. And in this case, I'll say US West 2. So this is the Oregon region. So for the Oregon region, you'll see US hyphen West hyphen 2. So if I was to change it, I mean, that's the quickest way. There are other ways also. So for example, North Virginia would be US hyphen East hyphen 1. So what essentially we are saying is allowing access to EC2 service to perform all the actions on EC2 service. And we're putting in a condition that the region has to be US West 2. Add the condition, add statement, and generate a policy. So this is what it generates. The first part is pretty much the same as we saw in the previous case, but with a condition. I'll just copy this. I'll just simply paste this policy. So we'll name it as the EC2 region restrict policy. Okay, so the policy has been created. We can filter it with customer managed. So this is the policies that you create, custom policies. They are being referred to as customer managed policy. So this is the one that we created. So I'll create a policy, let's say EC2. I'll add the user to this group. Okay, so let's try this out. Since we have granted access only to EC2, so rest of the services should not be available to this user. So which is good. Since we are in the Oregon region, which is US West 2, so the user is able to access. So if I try to actually go ahead and try to access EC2 in any other region, the access would be denied. So it is always good to have these kind of policies in place, else users can provision resources in any of the regions, and it would become an administrative nightmare for the admins to see where the resources are being provisioned. And the last part for the demo for custom is just provision a EC2 instance quickly. So the idea here is that we want to restrict the user from terminating the instance. So many times when you don't need virtual server or instance, you can actually go ahead and terminate that resource. So we are restricting the abilities of the developers. They should not be in a position to terminate. So only admins should be able to terminate that. So we already have this policy built. So I'll just simply add, rather, let's do it again. So this time, rather than selecting all actions, I'll start off with allow all the actions. So this is pretty much the same that we just did. And now I'm adding a second condition to it. And this time I'll say deny EC2. And I'm specifically saying that the user should not have the ability to terminate the instance. So in the first part, I said allow to all the actions. And the second part, I said deny to one of the actions. So deny would supersede the allow and generate this. So first part is pretty much the same that we saw in the previous demo. In the second part, what we are saying is effect is deny, service is EC2, action is terminate, resources is any resource. I'll just copy this. I'll simply go ahead and edit the existing policy and save it. So user still does not have access to EC2 in any other region except Oregon. I'll switch over to the Oregon region. I actually provisioned the instance in North Virginia region. So what I'll do is I'll just move over to the Oregon region just to demonstrate that resource created by the root user cannot be deleted by the dev user in this case. So now I'm logged in as dev1 and let's quickly see. So I'll try to terminate this resource. So it has generated an error. So thereby, I've restricted the user from termination. So specifically for higher environments, let's say production or UAT environments, you really want to put these kind of restrictions in place. Whereas if I do it with the root user credentials, so there are no limitations out there, I can simply go ahead and terminate. Managing users with IAM, we have already seen users in the console group, then you can always go ahead and delete them. You can rename your users using the CLI, delete the users. We have seen this. We've already seen managing permissions using policies, and policies are essentially your JSON documents. And you already have a policy generator. You can take itself to generate the JSON policies. So from AWS perspective, another security restriction, always follow the principle of least privileges, only grant permissions that are required by the user to perform their specific job function. So I've all seen these in the demo, create groups, attach policies, use managed policies. So managed policies are the ones that are created by Amazon and customer managed. So there could be a legitimate business need, as we saw in the later demos, that you actually want to go ahead and put additional levels of restrictions. These are the various elements of IAM policy: effect, allow, deny, action specific to a resource. So resource could be EC2. Principal is basically the username if you want to specify. So the sample JSON that we have on the screen is related to S3 service. So effect, it says allow on which service is S3, and we are specifying us only one action, which is list bucket, which means listing down the contents of the bucket. And to which resource are we applying? In this case, the name of the bucket is example underscore bucket. So the way we have done it for EC2, the same logic can be extended across any service or all the services that we are going to cover through the program. Then we have already seen creating policies for new user having admin or limited privileges. Best practices use IAM, access and permission management, delegation and audit I'll just cover. So these are the best practices that we have already spoken about. You can go up to the very finest level of controlling permissions with respect to a service in question. Then benefits, strong password policy where you set up your complexity requirements and way to expire the passwords based on your organization policy. So we have already seen how do we create access for users to log into AWS console. So now what I'll do is I just create a user and this time we'll grant him the programmatic access. So this would enable the user to access the AWS services via the CLI or the SDKs. So the service has generated the access ID and the secret access key. So this is the only time that you'll have to capture both the access ID and the secret key. Else the secret access key is never available. So we have downloaded the credentials. So I can go ahead and close this. So this is essentially the username and password for this. And we'll have to assign permissions that which this user has access to which service. So we can make this user a part of some specific group. So we'll make this user part of project leads, and project leads have already permissions assigned to it, wherein we have granted S3 full access. So this is how you do it. You need to have the CLI installer in place first. And once you have installed the installer, the first step is to issue AWS configure where you are authenticated against AWS. I'll just grab the access ID. So now I've authenticated against AWS, and the permission that this user has is full access permissions to S3. So AWS S3 MB, just let me see the right syntax. So the user has been able to create the bucket. So you can actually go ahead and check it out. So this is the bucket that we created using the CLI. Let me create a bucket. So let's say demo. Let's give it some name. So specify the region in which you want to set up your bucket. So make sure that when you create a bucket, just uncheck these options. All these are block statements. So just make sure that you don't enable them. So this does not mean that the bucket has become public. So we just created a bucket treated as a container. And now when I upload any data into this bucket, so roles are typically another way of granting permissions. And it is something that another entity can assume, and in doing so acquires the specific permissions defined by the role. So you can use role for a variety of purposes. Let's say you want to integrate your existing LDAP services with IAM, or you want one service to interact with other services. So the target service would need permissions. So you create a role that is sitting in silo, and the source service would assume that role. And in doing so, it would get the permissions that are applied to role. And that way it would be able to access the target service. So for example, if we are using a EC2 instance and it needs access to S3 bucket. So in this case, instance would assume a role from IAM with proper required permissions, and then the instance can perform actions based on the roles it assumes. But we should never pass or store credentials into EC2 instance. So roles are pretty important in that context. So by default, in this demo that we'll see, EC2 instance by default can have only one role assigned to them. So that role can have multiple permissions assigned to it in the background. So we'll go to roles. So we are creating a role for AWS service, and in this case, EC2. So I'll just simply pick up S3 full access policy that is being applied to this role. So this is the role that we created, and it allows the EC2 service to assume the role, but we'll have to actually apply it at the instance level so that it can assume this role. So just let me quickly provision an instance. So you have one of the configuration parameters during the provisioning process wherein you can assign an IAM role to the instance. In this case, we'll assign the demo S3 access role to the instance. So now this instance has a role attached to it, wherein that role has a permission to grant access to S3. So I really don't have to pass on the credentials to authenticate against the S3 service. So if I straight away go ahead and want to list the contents of S3, I can do that. I actually had to pass on the access key and the secret access key. So for now, just take it. I had access to EC2 instance, and from that instance, by virtue of role, I was able to access S3 service. Also, there are a number of types of roles that you can create. So let's say you can create a role between another AWS account. So now you cannot have users maintaining multiple identities, that in one account you have username and password, in the second account it will be different, and likewise. So how do we mitigate that kind of a situation? So you'll create roles across multiple AWS accounts, and in the target account you will be creating the role that would have permissions, and from the source account where your users are defined, that users would assume that role in the another account. Then you have web identity. So a lot of applications allow authentication via third-party platforms like authenticate with Google or Facebook or LinkedIn. So you can set up web identity as well using roles. And lastly, SAML 2.0 federation. So this is where you can integrate your Active Directories with IAM. So that ways you will maintain a single identity store, that is your Active Directory. You will define your users groups in Active Directory, and on the AWS side you will be simply creating the roles. So the user actually have to federate your Active Directory, establish SSO between your identity store and IAM. So that ways the users will have single credentials. So for logging on to their email or to their endpoints, desktops or laptops, they have only one set of credentials to play with. Principle of least privileges, manage permissions with group, and then restrict privileged access further with conditions. So let's say even if you're giving EC2 full access, so in the demo we said we are not allowing the users to terminate the resources, something like this. Then enable CloudTrail to be aware of API call logs. So in this case, how do I keep a track that which user is provisioning what resources, making changes to those resources? So there's another service called CloudTrail. So that actually keeps a track of all the API calls being made to your AWS resources. So that concludes IAM. So we'll move on to the next service, which is Key Management Service, of commonly referred to as KMS. So again, KMS is a region-specific hosted service that makes it easy to create and control encryption keys on AWS, which are used to encrypt data. So in the background, KMS uses hardware security modules referred to as HSMs commonly to protect the security and integrity of the keys. So before we get into the service, so there are two types of encryption that you can perform. One is symmetric and one is asymmetric. So KMS uses a symmetric encryption. So in symmetric encryption, you use the same key to perform both encryption and decryption. So that's principally because symmetric encryption is much faster as compared to asymmetric encryption. So in asymmetric encryption, one part of the key pair is used to encrypt and the second part is used to decrypt. So that's a pretty slow. And also note, any kind of an encryption comes up with an overhead. So that's going to kind of slow your performance. So with respect to data security, two important aspects. One is data security in transit, so that you can meet by implementing SSL, and data at rest, meaning security for data at rest, you'll have to use a specific key management service. So you can generate your own keys within KMS service, or you can import your keys. You can specify which IAM users or roles can manage those keys. And then you can set up a trail for key usage as well, which tells you that which user has been using the keys. So for protecting your data on cloud environment, or for that matter in any environment, you're more likely to use a service similar to KMS, and services similar to KMS would help you create your encryption keys and manage them, store them, rotate them at a periodic interval. So there are two types of keys in KMS. One is CMKs, which is customer master keys, and the second one is data keys. So data keys are actually used to encrypt and decrypt, whereas CMKs, which is the customer master key, is used to protect the integrity of the data key. So refer to this illustration that we have. So it is actually a twofold process wherein to the plain text, your data key is applied along with the encryption algorithm. So it is AES 256-bit encryption algorithm. So combination of both these two is applied to your plain text data. The resultant is your encrypted data. So we said that this is a symmetric key encryption and the same key is used to decrypt the data. So I can push this data to any storage of my choice. And now how do I decipher this data? So I'll need the access to the same data key to decrypt this. So either I keep the data key along with this, but then the entire purpose gets defeated. So the second part of the process is to protect the integrity of the data key. What you do is you encrypt the data key itself using the master key and more commonly referred as CMKs and apply the encryption algorithm. So the resultant that you get is the encrypted data key, and this encrypted data key is stored along with the encrypted data. So whenever you have to decrypt it, your CMK is applied to the data key that gets decrypted, and that decrypted data key is again applied to the encrypted data. So this is the workflow that actually happens in the background. So CMKs never leave the KMS service unencrypted. Data keys can. So two types of keys, customer master keys and data keys. So you can see your spend summary and based on which services that you have spent money on. So I spent almost 39 cents on Route 53. The rest are negligible. So it will give you the spend of previous months and additionally your top free tier services by usage. So in order to set up notifications, the first step is to go to preferences and you have to check these options, receive billing alerts. So this is first part of the process that you have to check this option, receive billing alerts. And in terms of setting up an actual alert, which is actually a notification in form of an email, we actually set it up in another service. So in this case, we're talking about AWS alerts. So alerts is a way of notification to a set of users. So in this case, our focus is on billing alert, but otherwise alerts could be about anything about monitoring the performance of your system and generating alerts out of it. You can set up alerts for your services going down or your additional resources being provisioned. So you can set up alerts for any kind of action within AWS. So in this case, since the focus is purely on billing, so you can set up billing alerts. As I said, first part of the process is receive billing alerts. So in order to actually receive the billing alert, you'll actually have to go to another service, which is CloudWatch. So CloudWatch is a monitoring service. So in the CloudWatch dashboard on the left-hand side of the pane, you have billing. So we actually have to be in the North Virginia region to set up the billing alert. So it does not really matter where your resources are, but you have to be in the North Virginia region to set up the billing alert. So this is where you will create your alarm, but you will be only able to create the alarm once you have checked the option in the billing dashboard under preferences. So let's say when your total charges exceed, let's say $1,000, just type in your address and it would send you alarms. Probably the last topic of discussion for today is AWS budgets. So with respect to cost management on AWS, we have already seen billing alerts. Budgets are another way that give you the ability to set custom budgets that alert you when your cost or usage has exceeded your budgeted amount. So you can track it on either at monthly or quarterly or yearly level basis. So in this case, you have created 7 budgets. So let's say you want to set up budgets across variety of projects. So in this case, you have Project Nemo and you have budgeted $45 for this project. So this is your current level and forecasted is 56. That means you are exceeding your budget by some percentage. So you could set up the budget on three types rather. One is cost, second one is usage, and the third one is based on reservations. So on your billing dashboard, you can go to budgets, create a budget. So for the free tier, the limit is you can create 2 budgets free of cost, but otherwise I believe you can create thousands, so nothing to worry about. So as I said, you could create the budget based on cost or usage. So let's say you're worried about the cost that will be accruing by using variety of services within AWS. So you will create a cost budget. If you are more concerned about the usage, there are a lot of variable factors in costs when you're using services. So you want to track them by usage. So I'm parking reservation right now because this is something that we have not touched. So this is essentially that you're reserving capacities with AWS and you get significant discounts in this model. So we'll just simply go ahead and create our budget. So in this case, let's say monthly EC2 budget. So let's keep it to monthly. So you could set it up as a recurring budget or monthly basis, or for one time you can specify the start and end dates. You can set up filters. By default, it is included all based on the service. So let's say Elastic Compute in this case. Then you have configure alerts. So you can set it up on the basis of actual cost and forecasted. So let's say in this case, I'll specify 80. So I'll be notified when the costs are nearing about 800. So just set up an email contact and you're good. So I have this virtual server is running. So I can go ahead and create a system alarm, or I can create another type of an alarm based on the condition that I want to specify. So in this case, CPU utilization, and these are the measures that are available. So you can choose either one of them to trigger out an alarm. So you want to set up aggregate CPU utilization of your, let's say 50 servers exceeding 70%. So you can trigger an alarm. So that alarm can notify people. Also, you can introduce automation by using this alarm wherein you can add more resources to it. Also, additionally, in auto scaling, alarms play a very important role.
So today we have gathered to discuss on Amazon EC2. So the main agenda for this entire session will be discussing on what exactly EC2 is, how it is structured, and how we can get started on using EC2 as one of the main services offered by AWS as a part of Elastic Cloud Compute. And then we'll be having a quick understanding of what exactly is AMI, as in Amazon Machine Image, how to define the security groups, key pairs, and tenancy, what is the main difference between Elastic IP and public IP, and different types of EC2 box configurations available, and what are different AWS storage services available, and how we can optimize the costing in EC2. That will be our main agenda for this entire session today itself. Let's get started on a discussion on EC2 as an Elastic Cloud Compute. So EC2 is a web service that provides servers in the cloud which are customized as per the requirement. So as we know, if we want to deploy any particular application, there are two ways of it. We can deploy the application in two ways. We can either buy our own servers, we can buy a stack of servers, and then we have to perform all the entire installation of all the operating system, the network, the drivers, the kernel, everything that we have, and along with the entire databases, everything has to be done at our own end, right? Or we can use the services already deployed over cloud. So again, here we have already deployed and pre-configured server that we can use, that we can, on top of which we can simply deploy applications automatically as a part of cloud service. And EC2 itself is just like we create multiple servers, we create multiple VMs as in virtual machine. So same way here we have EC2. So these are again the servers that we deploy over the cloud platform, and that can be initiated in a couple of minutes as compared to the deployment on the on-premise servers. So here it can be configured, it can be up and running in less than 15 minutes. That's how fast it is. And in here, it is highly scalable. So now when we talk about scalability, suppose if we want to increase the capacity of these servers, we want to increase the capacity of these servers from 2 cores of RAM to 8 cores. We want to add more RAM here. We want to increase the storage capacity as well. So we can do that easily. We can do that easily using the cloud computing platform as compared to the on-premise server, right? So that's the main advantage of, again, going for cloud platform as compared to on-premises. And the main advantage that we get on top of cloud services is it is highly scalable, plus it works on pay as you go model. So here we don't have to pay any upfront cost, because as compared to traditional, or we can say as compared to on-premise servers, because in on-premise servers we have to pay for setting up the servers, we have to pay an upfront amount for the infrastructure for the servers that we'll be buying, right? Whereas the cloud services, especially if you talk about our EC2, it works on a monthly billing cycle. So we don't have to pay any upfront cost or any fixed cost every month. And here we have to pay only for the amount of time we have used resources and the duration for which we have used them. That's the main advantage that we get as a part of EC2 deployment. And in terms of EC2, again, here we have Elastic Web Scale Computing. Again, it is highly scalable. It is highly flexible as well. Plus, again, it is scalable. That means if we want to add up resources, we can do that easily as compared to the on-premise server. Suppose if you want to increase the capacity here, if you want to add more number of servers, then that is done easily as compared to on-premise. Now, next is we have AMI. We have AMI. AMI is simply Amazon Machine Image. Now, just to understand this in simple layman terms here, if we are deploying any virtual machine, we do have to choose the operating system, right? Operating system, or suppose let's say when we are taking backups. For example, if we want to take the entire backup of our entire system here, what we do? We take a backup which contains not only, now this backup file, suppose if this is a backup, then what it contains is it not only contains the entire operating system, but it also contains all the configuration that we have done, right? It also contains all the files that is available on our entire system here, all the files, all the configuration, all the settings. That means entire particular system itself will be replicated if we are using this particular snapshot or this particular image that we have currently created, right? And suppose if we create an image out of it, right? Suppose if we create an image out of it, suppose as if we have a disk image for ISO, right? If we share this image to anyone, then using this image, suppose if they have a blank system, they can use this image to make a copy of whatever is present in this entire image. The entire configuration, files, and operating system can be replicated on their own system using the concept of images, right? And that's what images. So images are, now there are some predefined images which contains the predefined configurations that we can choose to get started with. Like we can choose the Windows instance, Windows AMI, we can choose Ubuntu, we can choose Debian, CentOS. Depending upon our use cases, we can choose these predefined images that we can simply use to install and set up our VM, or we can say install and set up our servers as an EC2 that we want, on top of which we can get started and start customizing on top of it, right? That is what we mean by AMI, Amazon Machine Image here. All right, next is we have security groups. So security groups is now when we are deploying servers, obviously as a part of server, server will be required to have a connection to as well, right? Because when we are deploying a server, we also need to have a connection, because suppose if we have deployed a server, now in order to manipulate, in order to work on the server, we need to establish a connection to the server itself, right? So which all ports will be used for setting up the connection here? TCP ports, HTTP, HTTPS, or SSH ports here. So which all ports will be used as a part of connection that we have to define as a part of security group, right? So in networking, we have multiple ports. So which port will be using for establishing our connection with the server? That is what we define as a part of security group. Suppose if we want this to be, suppose if we are using a TCP port, right? And now in TCP, we want the access of this one on port 8080. On port 8080, then we can define this as a part of security group. We want to access the server through the HTTP port here, right? Suppose here we want to define this as a part of HTTP, so that if we type in the IP and the HTTP ports here, again they will be able to allow us the access to the server here. So whatever port we want to add, we want the access to, we want the access from, we can define this as a part of security groups in EC2. So now let's erase this up. Now let's do one thing. Now let's move on to our hands-on, so that we can, so now we can discuss on each and every topic, seeing how exactly to get started on top of AWS EC2. So now let's log into a console first. Now, in case we don't have the account, or in case either we are having the account, in both scenarios, we can use this link as console.aws.com. So here we can use console.aws or amazon.com, which will take us to the login screen where we can start registering for AWS in case we don't have the account yet, or in case we already have the account, then we can log into our portal here using the AWS portal. So here we now suppose if we don't if we don't have the account here, we can click on create a new AWS account. In case we don't have the account yet, we can click on create a new AWS account, and this will take us to the sign up page where we can get started on signing up as a new user, just like we sign up for other websites. So here we can sign up for a new account here, guys. And once we move on to the next screen, we have to now, as a part of successful completion of the sign up process, we also have to pay, we also have to add our card details. It can be debit or it can be credit card, both. And again, in order to start, in order to activate our account for AWS, we do need these details. And AWS will simply charge our card for a nominal fee of 1 INR that will be reversed as well after it has been charged, just to validate the card that we have added is working fine or not, right? So we can use any of our card details in order to enter that in AWS and get started. So here, once we have the account created, we can log into our console. Let's go right back. So here we can enter our credentials. Just a moment, guys. We're just simply setting up the MFA again, because again, this as a part of making sure the entire account is set up properly, we do need to enter, we do need to set up the MFA here. Just a moment. Now, once we log into AWS, this will be our home dashboard that we'll be looking at. So this is our home dashboard on which we can get started. Now in here we can find, in here we have, in order to start with EC2, we have to search for the service called as EC2, or we can use a search tab to find any services on top of AWS. Because AWS, as we know, is a collection of more than 90 plus services, ranging from computation to management and governance, storage services, database, analytics, media services, mobile, AR, IoT. So these are all different services, in total of more than 90 plus services offered by AWS here. So here we have to start with EC2. So here we can simply select EC2 here, and this will show the list of all the active services into our account. So let us open up. So as you can see here now, in order to start creating the instances, we have to click on this option which says running instance. So using this, we can go ahead and we can go to the instance that is currently being deployed, that is currently up and running into our account. And again, if we want to get started on creation of a new instance, we can click on launch instance, available on the top option. Here we have launch instance. Let's click on it. Now, as a part, just like we create any virtual machine using, if we create any VM, first of all, we have to choose the base image as an Amazon machine image, AMI. So there are multiple predefined AMIs available as a part of our AWS account, so that we don't have to worry about using our own AMI. So we can use these as a base AMI. We can use these as a base application. Also, we can say base operating system and configuration, on top of which we can get started on deploying our own application on top of these. So here we can choose from a simple Amazon Linux server. We can choose Red Hat, SUSE, or Ubuntu server. Again, we can also choose multiple instances of Windows servers, Ubuntu. Again, there are multiple AMIs from which we can choose and get started, right? So we can choose any of these AMIs here. Now, as a part of our hands-on, we'll be choosing the Ubuntu server AMI. We can click on select. Now, in here in this screen, we have to choose the instance type. When we say instance type, we simply mean the server type. That means what exact configuration we are looking for in order to deploy this entire server here. So as you can see, currently we have T2 micro selected. Now, as a part of our new AWS account, we get selective services that we can use under limitation for free. right? So they have some, as a new account, if you register for a new account on AWS, then we are given a couple of services that we can use for free under certain limitations, right? Where T2 Micro is one of those free services. And as you can see here, currently we can see the list of the name of all these different services as in instances, and how many cores of CPU they have, how much of RAM they have, and again these different storage types that they are available as a part of this entire deployment here. Suppose we want 1 core of CPU and we want 1 GB of RAM. If we want, suppose if we want the 48 cores of CPU and we want 192 MB of RAM, we can choose. And again, we want two 900 MB SSDs as a part of the storage options here. Then we can choose these accordingly. So depending upon our configuration, the cost will also change accordingly, because the higher the amount of resources we use, the higher the billing would be, because again these resources will be expensive, and that's why we have to pay a higher amount of money as compared to the lower, or we can say low resources, as in 1 GB of RAM and 1 core of CPU. So as an example here, we want to deploy the application on a free tier account here, having 1 core of CPU and 1 GB of RAM. We can click on configure instance detail. So here we can choose the T2 Micro. Now next is we have to click on next configure instance detail. Here we can choose the instance number of instances, that means how many instances we want to deploy here. We can this part is mainly focused on the networking. Suppose if we want to create our own VPC, we want to create this on our own VPC, our own virtual private cloud here, then we can deploy this easily. And in this part here, we'll be focusing once we start a discussion on VPC itself. So we can leave this as it is for by default. Next is here we can add storage, as in what that means. In server, we also need to work on servers, right? And what kind of storage we will need in order to deploy the server instance here, that we have to define as a part of storage services. So here we can define how much of space we require for this entire VM that we are trying to create here. We want to use 8 GB of storage, we want to use 10 GB of storage, we want to use 100 GB, 1000 GB, depending upon our use case. Suppose we wanted to deploy this with 15 GB of storage, and in here we can choose the storage type. We mainly use general purpose SSD for we can say for a balanced. Okay, wait from someone. Yeah, so basically we use general purpose SSD for a balanced performance, where we can get good performance as compared to other storage devices, because SSDs are generally faster in read and write access and read and write speed as compared to other services, right? So here we can choose general purpose SSD, and then we can choose the provision IOPS, especially when we have any data centric application. If we have any database applications, then we can choose data, or we can say provision IOPS. And then in terms of any cold storage, if we are using this just as a backup, we are not using this for an active installation, then we can go ahead and use magnetic. So for our hands-on here, we'll be using general purpose. Then we can now, and in here once we add storage, then in here we can add tags. We can leave this blank for now, and then we can define security group. If we now by default we will be trying to access this via SSH portal, and now if we want to access this instance, this server also, suppose if we are deploying a website, then website will be opened up using the HTTP host itself, right? HTTP or HTTPS, right? So if we are deploying a website, then we have to choose the HTTP and HTTPS ports as a part of protocol, as a part of security group that we had discussed. So here we can click on review and launch. Once we are done, we can launch it. And as a part of configuration followed by AWS, each and every instance is highly secured using the concept of encryption. So the entire data available on the server that we deployed here is highly encrypted. And if we are trying to access this, if we are trying to make changes to this instance, then we have to then we have to use the key. That means until unless we have the key that has been generated by AWS, we won't be allowed to connect to the instance. We won't be allowed to do any changes on the instance until unless we have the right key selected and deployed here, right? So here we can simply, now here if we want, we can go ahead and create a new key pair. We can click on create a new key pair. Suppose we want to name this as nav21. We can create a new key pair. We can download this key pair and click on launch instance. Now remember to save this key pair that is downloaded as a format of in the format of .pem, because we will be needing this key file in order to connect to this instance, without which we won't be allowed the access. So without this key that we are currently downloaded, we won't be allowed the access in any case. So we have to make sure that we do end up saving this entire authentication code itself. And once we are done, we can simply click on view instances. So as you can see, now we have the instance up and running here, right? So now here we can, now once we have the put, now let's see how we can connect to the instance that we have currently deployed here. So here we can simply go ahead and open up PuTTY. First of all, now if we are using PuTTY, first of all, we do need to convert the .pem file as a, now this is what a simple key that we have currently downloaded, which we will need in order to connect to this instance, right? So first of all, in order to use it with PuTTY, we have to convert this .pem file to .ppk as PuTTY public key, because PuTTY needs ppk key files in .ppk format, not in .pem. So here for converting .pem into .ppk, we can simply use a tool called as puttygen.exe, which we can download from the link that I have shared with everyone. So here we can download putty.exe and puttygen.exe as well, right? So here we can open up puttygen.exe, and in here we have to click on load. Now, once you click on load here we have to go to the folder where we have downloaded the current key file in .pem format. So if we choose all files and downloads, if we search for .pem, we can, now this is a key that we have currently downloaded, that we have currently used for the instance that we have currently deployed here, right? For this instance. So now what we can do, we can simply go ahead and open this up, click on open. And now we have to click on save private key. And let's save this on desktop with the same name as nav21.ppk. We can save it up. Now, once we have saved the key as .ppk, we no longer need this key. So we can close it. And now we can open up putty.exe. We can open up putty.exe. Now, once we have converted the key here, then we can simply open up putty.exe, where first of all, we have to enter, now in order to connect, first of all, here we have to enter the host name. So we can enter, so now we can enter both the public DNS or public IPv4. We can enter both. We can copy this. We can copy this under host name of IP address. We can enter this IP. Port number will remain as it is, as port 22. Then under connection, we have data. So under data, we have to enter something as Ubuntu. And under Ubuntu, then under SSH, here we can expand SSH. And under auth, we can define the key that we are currently trying to create here. So we can use a key that we have currently converted, that is november21.ppk. We can open this up. And now if we don't want to do the same step each and every time we are trying to connect to the instance, then we can save this as a profile. So let's name this as nav21 itself. Let's save it. And now if we double click here, we would be, now if the credentials are correct, if the key that we have chosen is correct, we would be able to log into the instance here. As you can see, now we have got the access to the instance, and now we can start communicating it as a part of CLI. Let's increase the font size, as we don't want to strain our eyes here. Let's increase the font size. So that's how we can get started and get connected on top of EC2. Now, once we have the connection, we can start manipulating EC2 service exactly as per our requirement. So in here, we can, now, if we want, now this works like a simple shell scripting, right? So if we are clear, if we are comfortable with shell scripting, this works just like a shell scripting here. So in here, we can now, in order to get the complete access, we can convert ourselves to the root user using sudo su. Now, if in case we have chosen the default Linux environment, then we could have chosen yum, right? And in here, since we are interacting with Ubuntu, so then we can start using all the sudo commands, right? So like for example, here we have converted ourselves to the root user. We can clear this all out. And then suppose if we want to update or resync all the services, we can use apt-get update, where each and every packages will be updated. Suppose if we want to install Apache tools, we can simply go in apt-get install Apache 2. So here we can simply run and set up Apache 2 here. So once we are done, so since we have also chosen HTTP port as well for this entire instance, right? So once we are done installing Apache 2, if we open the same IP into the web browser, we would be able to see the default Apache 2 page being opened up in the browser. So let's wait for this entire instance to be executed. This which may take a couple of seconds. So as you can see, now this entire setup is done. So if we come back, if we copy the public IP here, if we copy this in and paste this in browser, as you can see here, since we are done with installation of Apache server, now we can see the Apache 2 Ubuntu default page being opened up in the browser in the instance, in the EC2 instance that we have currently deployed here. And that's how we can start manipulating it. That's how we can start working on top of it, right? Let's also discuss shortly on top of the IP addresses. Basically what we have is in AWS, we have something as public and elastic IP as well. So we also have something as public and elastic IP. So when we deploy EC2 instance, what we have is, now as you can see here, we have the IP being automatically assigned to the instance that we have currently created, right? But this IP, suppose if we no longer need these instances, we can simply click on actions, instance state, and then we can terminate these as well. When we say terminate, that means we are simply killing off the servers. That means we cannot restart this if we have killed it, if we have stopped this, if we have terminated this, right? If we stop their services, then we can restart them. But again, if we terminate them, then again, these entire servers here will be terminated. So I think we have terminated that. So here, once you click on launch another instance, if we choose to launch another instance here, click on select, review and launch. As you can see, these two have been terminated. Let's remove these. Now we have one instance up and running here. So as you can see, currently this IP address has automatically been assigned to this instance, right? And now if we stop this instance here, now currently we can note down it is 13.232.108.136. If we stop this, and again if we restart the same instance, then a new IP will be assigned here. So every time we start and stop and restart, the servers here will be assigned a new IP to the servers, to the instance that we are currently deployed on top of AWS, right? And so this entire public IP that gets reassigned every time we restart the service, this is referred as a public IP. This is referred as a public IP in EC2. Whereas if we don't want this IP to be changed every time we are restarting it, then we can choose something as elastic IP. We can choose something as elastic IP here. So if we click on start here, again, if we start the instance again, a new IP, a new fresh IP will be assigned here. So let's wait for a second for this one to be up and running again. As you can see now, fresh IP has been assigned here. And basically the use case for the, and again, and if we do not wish to change, if we do not wish to change the, or have the IP change every time we are starting and restarting or stopping the servers, starting or stopping the instances here, then we can use something as elastic IP. We can use something as elastic IP here. So the main, so again, a simple use case for this one would be, suppose we have an office, right? And any office here, suppose they're using an enterprise solution. Now they are using a solution which is used by their workforce from 9 a.m. in the morning. And kindly excuse for this beautiful calligraphy, guys. That's what happens when we try to write using our mouse pointer, right? So again, in the office, guys, again they are planning to use the application from 9 a.m. in the morning till 6 p.m. And that means from 6 p.m. in the morning, 6 p.m. till next morning 9 a.m. the application will not be used, right? The application will not be used. That means here we are simply wasting 15 hours of our work time here, right? So for 15 hours straight, this entire application will not be used. That means the entire servers will not be in use here, right? So instead of keeping the server on and which will be adding to our billing, because this works on a pay-as-you-go model, what we can do, we can turn off, or we can say we can stop the servers in this time period, right? But whenever we are stopping it, the IP attached to this instance that we are currently using here will be changed every time we restart them, right? Suppose that the same application is used by 1,000 users, then again we have to reshare a new IP to those 1,000 users every day, becoming and increasing that, we can say making it a more tedious task, right? So instead of doing that, what we can do, we can simply assign something as elastic IP, which will remain static, which will not get changed even though we stop the servers, right? So then in that case, even though we have stopped the servers, again, if we restart, the IP address will not be changed. And that exactly is what we mean by elastic IP here, being one of the use cases. And now in order to issue an elastic IP here, we can simply go to elastic IP. We can allocate a new one on, obviously elastic IP is a paid service offered by AWS. And when we say paid service, as long as that IP, this elastic IP is being used, we don't have to pay. But if we generate an elastic IP, and we are not using it, that means we have not associated that IP with any particular instance, then we have to pay for the unused elastic IP. That's a concept here. So here we can just simply click on allocate, and once this IP has been allocated, we can close it. And now if we want to associate, we can click on associate address. We can choose the instance that is up and running, click on associate. And now if we come back, if we close it, if we come back to instance, now even the IP now has been converted into blue, right? And that means even though we start and stop the services, this IP will not be changed at all. So the main agenda for today's session here would be, we'll be discussing on AWS storage services. We'll see what exactly storage service is offered by AWS. What is Amazon S3? What do we mean by buckets and objects? How we can take care of versioning and cross-region replication in S3, how we can take care of transfer acceleration, and then we'll see the S3 demo and its multiple use cases as a part of our hands-on. All right. First of all, let's get started on understanding the storage services offered by AWS, right? So AWS offers multiple storage services. Now, first of all, we have Elastic Block Storage, then we have File Storage, then we have Glacier, right? So here we have multiple storage services, and then we have Storage Gateway, and then we have S3. Here we have Storage Gateway, and then we have S3, right? Now, when we talk about block storage, now let's understand these one by one. If we talk about block storage, and block storage is basically useful for storing of multiple files as a block, right? Now, block storage will be obviously can be used for storing unformatted, or suppose we can say unprocessed or raw data, right? Where multiple data set are being stored as a complete block, right, in different regions, right? So that's why we can store these components as a block, right? File system are used for storing of files, like we said. Now, let's suppose here we have multiple file system that we need on a frequent basis, right? Then we can use EFS for that. Then we can use EFS for storing those files which can be used, which we need on a frequent basis, right? Glacier is basically a service offered by Amazon where Glacier is basically focused on storing archive files, right? That means those files which we do not need on a regular basis. For example, say if no, no, if a company has records for its financial has its financial records for suppose from 5 years back, right? So obviously company doesn't need those 5 years old financial data on a regular basis, correct? So that financial data may be required in years or any particular use case, especially in multiple years, right? That's why now this kind of data does not need to be accessed on a regular basis or not even months, right? So this can be stored as a part of Glacier service where these data can be stored. Now, the cost of storing these data will be much lower in Vault because these are not accessed frequently, correct? And then we can store them in this in as a part of as a part of S3 Glacier. All right. Now, next we have storage gateways, right? Now, the storage gateways are mostly used for when we are transferring files from our on-premise server. Suppose let's say we have on-premise server here, right? And let's suppose here we have 50 GB of data that needs to be transferred to AWS, right? So now, instead of transferring these files directly to AWS, right? So what we do have something called a storage gateway in between. It's again the main purpose of storage gateway is simply make sure the data is transferred smoothly and without any breaks and being uploaded to AWS servers here, right? And again here it contains multiple protocols, like we had TCP, we have multiple multiple switches and gates present here, so that it makes sure that the data is transferred smoothly from on-premise to AWS as a part of storage gateway. All right. And S3 is a part of the object storage that we have seen earlier, correct? Object storage is a part of the S3 is a part of the object storage where we can store multiple files as a part of S3 storage that we'll be exploring step by step. All right, so now let's proceed further. Now let's understand what exactly is Amazon S3. What do we mean by Amazon S3 here, right? So S3 has a simple interface that we can use to store and retrieve files of any size at any time from anywhere, right? So whenever we want to store any kind of file, suppose we want to store documents, we want to host our static website, we want to store the backups, we want to store logs. So all of these things can be stored inside S3 and inside Amazon S3 storage, right? Now, when we talk about S3 simply means simple storage service. S3 is what? Simple storage service as a service offered by AWS, right? So it contains three S, and that's why it has been abbreviated to S3, right? So that's why we have 3S here, and that's why we call it as Amazon S3 storage, simple storage service. Right, so now S3 can be used for storing any kind of data. It can be used for storing any kind of data. It is more durable. It is flexible. We can have now we is always available at any given point of time. Durable as in because here we can encrypt the data and make sure our data security is intact. Flexible because we can scale up and scale down the resource exactly as per exactly as required, right? And we can access the data anywhere from any time. It is available. That is, we can access the data at any point of time. So there's no restriction on the retrieval and storage of data that can be done at any point of time, right? It is cost efficient. That means obviously as compared to other providers for the block storage, it is much cost efficient as compared to the other one, right? Then it is highly scalable as well. It can meet the requirement for us. Suppose if we want to scale up the resources, if you want to scale down, that means if you want to increase the storage or decrease, then we can do that easily using S3, right? Again, it's more secure because of multiple encryption methods already put in place as a part of S3 storage. All right. Now in S3, we have multiple classes. We have standard, infrequent access, and glacier, right? For example, now let's understand this in a much better way. And for understanding this, let's go back, let's move to our Picasso mode. Let's move to our Picasso mode here. Now in storage options, we have three classes. In storage options, we have three classes here. We have standard, we have infrequent access called as IA, and then we have glacier, right? So standard in standard class, what we do, we store all the files which we require on a frequent basis, right? For example, let's suppose when we are now, suppose if we have a website, right? If we have a website, now in that website, we are showcasing the gallery of the recent event. We are showcasing a gallery of the recent events here, right? Now these files needs to be accessed. These files are needs to be shown to the users who are on the website on a regular basis, right? Since these are recent files, that means now what we can do in the website, we can store all of these images as a part of standard class in S3, right? As a part of standard class in S3, right? Because this needs to be accessed. These needs to be accessed on a frequent basis. That's why we can store this in standard, because in standard, the data can be fetched quickly because it is available 99.99%, right? So the availability of these standards are really high, and it can be fetched within milliseconds as well. So if we do need to access these files, it can be fetched in milliseconds, and these are highly available, right? So all those files, now this can be PDF documents, this can be static files, this can be any kind of file, and there is no limitation as well that there is no limitation in terms of the file that we can store as a part of a standard, right? And we can now in standard we can store files as low as, so there is no minimum requirement as well. That means we need to have files only for suppose 1 MB or so. Also we can store files as low as 1 KB as well, right? So you can store files as small as 1 KB as well, right? And all those frequent files that we need on a regular basis, that can be stored as a part of standard class. All right. Now next is we have infrequent access. Right? So in infrequent access, what we do, we simply store those kind of files which we do not need frequently, but if we need frequently, then it can be fetched at a then it can be fetched quickly, right? For example, suppose here we are storing on, let's take the same example for gallery, right? Now this gallery is for 2019. So obviously this will be required to be fetched frequently, more frequently than any other classes, right? And here, suppose here we have a gallery for 2018 or 2018 or 17, right? Or 17 here. Now again, we have the images here stored, correct? Now these images are not that in you or not that much in use, or they're not requested as high as 2019, correct? So what we can do, we can store these as a part of infrequent access, so that this can be stored in a separate class for infrequent access, right? Now this will not be, not the availability of these images will be 99.9%, right? Not 99, but 9%, right? But whenever we need to access these images, we can fetch them easily by using millisecond here, right? So this can help us in again making our entire storage more structured, correct? So these are not available as high as frequently as standard, but in any case, if we do need to fetch these data, then that can be done as quickly as possible as well. All right. And all of those files which are not required frequently, we can store these as a part of infrequent access here. All right. Now, and there's a limitation also available, guys. So in standard, there is no minimum duration for which we want to store the file, which we need to store the file for. We can store the file for suppose for 1 minute, and then we can remove it as well, right? But in infrequent access, there is a requirement. That means if we move the files to infrequent access, then we have to keep the file in infrequent access at least for 30 days, right? That means we can fetch the files, we can do that, but we cannot remove the files once we have moved them to infrequent access at least for 30 days, right? So that's a limitation for infrequent access. So now let's move to Glacier. Now in Glacier, let's say if you go back to Glacier here. Now, in Glacier, we can now, let's suppose here we have some files. I suppose if we have the files, now we may have seen this also in our practical example. Now, if we want to download our entire historical data from Facebook, right? If we want to download our entire history from on Google, right? Like from Google itself, right? Then when if we request the access of our of for downloading entire historical data, it simply says as okay, we are preparing your entire historical data and it will be available within next few hours, right? So now what happens? Now, since these data are not required on a regular basis, so what we can do, we can store this as a part of Glacier, as a part of Glacier service, right? Where we do not need to fetch these data on a regular basis, correct? And that's why if now we can store this as a part of Glacier, right? So that now when we move something to Glacier, obviously here we can store files on like on a bigger volume, but the access will be much lower. For example, if we want to fetch something from Glacier, we have to wait at least for 4 hours. For 4 hours as a normal waiting period for for fetching the files from Glacier back to our own storage, right? And there's a minimum duration for 90 days. That means if we move any files for Glacier service, then we have to store them at least for 90 days, right? And again, although we can increase the speed of fetching the data, but again we have to pay for that particular fetch, right? We have to pay extra for increasing the speed of fetching process, right? And here again, we cannot store the files lower than in a standard. We had seen we can store files as low as small as 1 KB, correct? But again, there we have storage. We have limitations on the file storage as well, right? And here there are additional fees for every retrieval here. For example, here we have to pay fees per GB of retrieval, right? Suppose let's say we are retrieving data for suppose 5 GB, right? Then there's a price attached to per GB of data that we can retrieve from Glacier and as well as from infrequent access. All right. All right. So now let's remove our kindergarten drawing here. It looked like a kindergarten kid had drawn something. So now let's remove this and let's get right back. And as we have seen here, now the durability, each and every service is highly durable, but in terms of availability, here it is available 99.99% of time. Here it is the infrequent access is available 99.9% of time, and Glacier is not available because here we have to manually request the retrieval of data. That's why it is not available, right? Now here there is no limit on the, now in standard there is no limit on the minimum amount of size of file that we can have. In infrequent access, we need to have files as at least for 120 KB, right? And there's no limit for Glacier as well. Same way in terms of minimum storage duration, there's no minimum period required for standard, whereas for infrequent, we require to store the files for at least for 30 days, and in Glacier, we need to store them at least for 90 days, right? And again, first byte latency, that means in case we are trying to retrieve the files, it can be fetched in milliseconds, right? In infrequent and standard, but in Glacier, it is at least 4 hours, right? And there is no retrieval fee for standard, but there is a retrieval fee per GB for infrequent and for Glacier. All right. Now let's discuss on buckets and objects, right? So in S3, what we have here, we have multiple concepts of buckets, right? So bucket is simply, we can say a storage bucket, right? Where we store multiple objects with their metadata as a part of bucket, right? So for example, so now here we can create multiple buckets. For example, here we can create multiple buckets here, right? So bucket, we can say it works like a container. Bucket here works like a container here, where all the media files, for example, let's suppose here we have audio files, here we have video files, here we have some PDFs, here we have suppose any website for the entire HTML files for the website, right? So all of these are referred as objects here, right? So bucket, we can say bucket is referred as a container which will house all the objects stored inside that particular container itself, on inside that bucket itself, right? And in one S3 storage, we can have multiple containers. We can have multiple buckets, right? So as a limitation here, now one account here is offered 100 buckets. That means we in one account we can have hundreds of buckets, and then we can have 20 buckets defined for one region as a part of a free account for AWS, right? So here we can have 20 different buckets, right? Stored in in a single region, right? And then each and every bucket can store its own type of files, right? Suppose, and here we can keep on storing multiple files exactly as per our requirement as a part of the bucket here, right? And each and every object also have its own metadata. Now, when we say metadata, it simply includes all the keys, all the versions, all the title, description, and everything, and every kind of metadata is also stored along with objects as a part of the bucket here. All right. So bucket here is unlimited, and again, when we are storing any kind of files, it cannot be greater than 5 TB, as we have seen here. So we cannot, that means we can have multiple buckets with unlimited size, right? And again, this object that we are storing here, for example, is suppose here we have a media file, right? Here we have a media file, or suppose if we are storing a backup here, right? Then the backup size cannot exceed 5 TB in total, right? So a single object cannot be greater than 5 TB in total as a part of S3, 5 TB here. So in AWS, we have 100, now we can have a total of 100 buckets, whereas in one region, we can have 20 buckets, right? So suppose in one region we have 20 buckets, in another region we have 5 buckets, in another, suppose in another region in third region we have 8 buckets, right? So we can distribute them, but in total it will not be greater than 100 buckets in total. All right. All right. So now let's move forward. Now, next is we have versioning and cross-region replication. Okay, first of all, let's see, before we move to the versioning here, let's see how we can get started as a part of our hands-on on creation of multiple buckets and objects, right? So let's go ahead and do that. Now, first of all, we need to log into our console for AWS. So here we can log into our console. Let's do it. Now, for logging into console, we can simply type in login console.aws.com. So here we have to enter the MFA code for our account. Let's enter it. Now, once we log into our AWS, this will be the dashboard that we will be looking at. So now we can search for, now we can use the search bar. We can use the search bar here, or we can use the search bar available on top as well as a part of S3, right? As a part of services. So here we can search for service named as S3. So here we have S3 service available. And now this will take us to the simple storage service dashboard, where we can see the list of all the buckets that we already have in place here, right? So here we can see we have the list of all the buckets that we have already created, or in case we have no bucket created, or if we want to create a new bucket, then we can simply tap on this option which says create bucket, right? So let's click on it. Now, once you click on create bucket, here first of all, here we have to define the bucket name, right? Suppose we want to call this bucket as Edureka and sept. Okay, we cannot start the bucket name with any uppercases, right? So here we have Edureka September. So you can write the name as Edureka September. Now we have to choose a region in which we are deploying the bucket on, right? Now region selection is really important. Why? Because let's see. Suppose we have a user sitting in US, right? Suppose a user is sitting in US, and here we have users sitting in, suppose users who are based in UK, and then we have users who are based in, suppose in India, and then we have users who are based in, suppose in Australia, in AU, right? Now suppose if we deploy any bucket in US, right? If we have deployed any S3 bucket in US, then again it will be much easier for the US audience to access the data using this bucket than accessing the data in the bucket deployed in UK region, right? So again, if we have deployed a bucket in UK region, suppose now US audience can be, now they will be able to access the data stored in the bucket deployed in UK region, but the rate and the latency will be much higher, right? That means the time duration in which they need to, the time that they need to access the data, to store the data, or to fetch the data will be much higher, correct? And that will slow down the performance, correct? And that's why it will be much better if they access the data stored in the own region itself, right? Same for Australia, same for India as well, right? So although they can be accessed to multiple regions, we can do that. That means US can also access the bucket for Australia. US can also access the bucket for India, but the performance will be much lower as compared to accessing data in their own region altogether, right? So we have to make sure that we create the bucket in that region which is closest to our users, so that they can have a better performance. All right. So now let's assume on our hands-on creation of a bucket. So first of all, we have to go to the S3 service in our AWS console. Then here we can click on create bucket, and now we have to define the bucket name, and then we have to choose a region in which we are trying to deploy the bucket in, right? For example, suppose we are now here we can decide here we can choose between any of the regions. We can choose from Mumbai, Ireland, London. So in terms of regions, then we have 21 regions deployed globally by AWS in which we can choose from, right? For example, suppose we want to deploy this bucket in Mumbai region, we can choose Mumbai. Next, we can click on next here. Now, if we want, we can again keep all the settings by default. Now here we can decide if we want to block all the public access. Suppose if we want to make this entire bucket private, then we can keep it private. Or if we want to allow, or if we want to allow the access to the public for this bucket, then we can remove the public access from this part, right? Now, first of all, now here we can block all public access. Now in this option here, we can block the public access to buckets and objects granted to new access control list, right? Now here in AWS, we have a concept of ACL, right? So here we can define multiple ACLs. And again, if you don't want this to be accessed through new ACLs, now we already may have defined multiple ACLs before, but again, in terms of new ACLs, we don't want to give the access to, then we can uncheck, then we can check this option, right? If we want to block the access to our bucket through through any of the ACL, then we can choose this option, right? Now, and third one is if we want to block the access to the bucket granted through new public bucket policies. Now here we have multiple policies that we can attach to any user or any group, right? Suppose if we want that any new user having a new policy attached to them, right? Now we don't want this bucket to be allowed to the access to those new users and new policies. Then we can attach it, right? And again, if we don't want this to be accessed by any user having any kind of public policies for bucket, then we can uncheck this one as well. Now, once we are done, then here we can review all the settings that we have done for the bucket. And now click on create bucket. So as you can see here, now we have the bucket created that we had deployed as a part of our S3 bucket, right? So here we have the bucket named as Edurega September, in which we can start uploading files, right? We can start adding files to our bucket that we have created. So now we can click on get started. And now we can start adding any files here. For example, let's click on add files. So now we can go ahead and choose any files here. Let's do that. Okay, let's say we do one thing. Let's upload any of the files that we want to upload here. Let's suppose here we are trying to upload one particular file that we have, a small file that we have which contains a small application, right? Let's suppose we want to upload the zip file here, right? Next is we can define the ownership. That means the access that we want to grant to this particular user, right? Now here we have multiple storage classes that we have discussed, right? So by default we have standard, and then we have 3 levels of infrequent access, right? So these are 3 levels of infrequent access. We have intelligent tiering, then we have standard IA, and then we have one zone IA, right? And then here we have multiple Glacier servers. All right. And then we have multiple Glacier servers. So if we want, we can choose between any of the classes here. Suppose if we want to start by standard, click on next, and now we can click on upload. Now, as you can see, as soon as we have clicked on upload, now the file is available as a part of bucket object here, right? So same way we can again here, if we want to create multiple folders, we can click on create folder. Suppose we want to name this folder as images, right? We can create images. Click on save. Now we have folder for images, and now if we want to start adding images here, we can do that easily. So again, we can click on upload. We can click on add files, and now we can choose the images that we want to download here, right? Or or images that we need to upload here. Okay, let's do one thing. Let's upload some pictures. Just a moment. Let's suppose here we have selected these three sample images here. We can click on next. And now we can choose the classes here, correct, as standard. And now we can click on upload, right? So now what we have, now we have these three images available that we can all and if we now as we had discussed, the object that is getting stored here, they all have their own complete metadata as well, right? So if we click on any of these objects that we have selected, here we can find the all the metadata. That means the current size, keys, the versions, the source, all of these things are already attached to the object that we have currently uploaded, right? And now if we want to share this part here, again, what we can do, we can simply make it public, right? And now we have the link available so that now we can share this link with anyone and they'll be having the access to the image that we have currently uploaded, as we can see here, right? So now we can simply share this link with anyone and now they can have the access to the file that we have shared with them. All right. Now let's do one thing. Let's say we upload the files for a sample website that we had as a sample dummy website, right? So let's do it. And for example, let's say we go back to our desktop. Now let's say we have a static website here, right? Suppose we have a static website, a static page for edureka.html, and we have navigation.png as well. And then we have multiple CSS folder for it as well. Now we can click on open, click on next, and now let's add this in the same standard class as a part of the bucket. Let's click on upload. So now as you can see here we have the standard HTML file with Edureka with navigation.png also available, right? Now let's do one thing. Let's make some changes in this HTML file. Let's do that. Let's go back to our folder. Let's make some changes for this Edureka file in our HTML. As you can see here we have a simple file, right? So here we have dummy website that we have created as a part of our as a dummy website, right? And now let's suppose we do one thing. We do make some changes in this file. Let's say we add another, suppose let's say we add one thing else. Let's suppose we add any particular paragraph, for example, sample paragraph, right? We have a small change. Now let's do one thing. Now let's upload the file back to our AWS, to our S3 bucket, right? Again, we can click on upload. Now, as you can see here we have the file already available. Now we have made some changes and now we are uploading the same file again, right? Add files. Again, we can save the file. As you can see now, this is currently updated, right? So we can upload this file, click on next, the same class as standard, and now upload. Okay, why this will not work? Because first of all, we have missed on enabling version first, right? So first of all, before we can maintain versions, we do have to make sure that we enable versioning in our bucket, right? So how to do that? First of all, you have to go to properties. Now in properties, we have a we have a property enabled here, right? So here you have a property named as versioning, right? So we have to open this up, and now here we can click on enable versioning, correct? So now if we click on enable versioning, then save. Now remember, we have to enable versioning for keeping the record of the versions in this bucket, right? Without this, versions will not be maintained. All right, guys. So here we can enable versioning in the properties tab. Once we have enabled this, now we can come back to overview. And now let's make the same change again. Now suppose again, if we go back, if we add, suppose again, another paragraph, right? We are learning S3 storage, or just S3. We save it. Now let's go ahead and upload the same file. It is currently updated. And now click on next. We choose the same class and now upload. Now as you can see here, now this file has been uploaded, has been updated, right? And now if we want to see the previous file, the previous version of the same file that we had uploaded, for seeing that, what we can do here, we on top we have an option called as versions, right? So after we enable version, we'll be seeing this option as a part of our S3 bucket, right? So to see the previous version, we can simply click on show, right? And as you can see here, Now we had two versions of HTML, Edureka.html, and then we can see this as a version. So this is the latest version, and this is a previous version that we had uploaded. All right. Now, let's suppose if we have to host a static website, then what we have to do, we have to go to back here in properties, we have to enable something called as static website hosting, right? So we have now this will enable us to host any static website. Again, not dynamic, but static website in S3 bucket, right? So here we can click on use this bucket to host a website. Now here we have to define the index document. When we say index document, we simply mean the root file, or we can say the home page, right? For example, in our S3 bucket, we had uploaded 10 files. We had uploaded 10 files there, right? Now suppose we have 10 HTML files. Now which file will be treated like a home page, right? That page has to be defined as an index document, right? So currently, suppose if we want edureka.html to be treated like a home page, right? Then we can mention this as index document, correct? Error document is just like we have 404 pages, right? Suppose and if any error happens, then which page should be treated like a 404 page? Then we can define here. Currently, we don't know, we don't have that page created. Then again, if we would have, then we could have mentioned this, right? Suppose if we did have a page called 404.html, then we could have added this as an error document, right? And now click on save. So now what we have done, now we have enabled static website hosting as a part of our S3 bucket, right? And now we can combine this with another service that is CloudFront. So now what we can do, now once we have this one created, now we can go back to our versions here. Now suppose here we have the website here, right? Here we have the website. So now if we want to see this website in live preview, what we can see here, here we can click on the file, and now we have the static website being deployed, right? As a part of S3 storage here, as a part of S3 storage here, right? And if we want to see the again, if we want to deploy this, this website using a temporary URL offered by AWS, then we have another service. Which is called as CloudFront, right? So here we can look for the service named as CloudFront, here, right? So CloudFront is basically a content delivery network offered by AWS. So here let us open that. And again, if you want, we can click on create distribution, get started. Now here we can choose the default name. Now here it will be the same. Now here it will be the bucket in that we have created, right? So we had the bucket in as Edureka September 3, right? And now we simply have to choose the default bucket name. Everything else will remain same. We don't have to worry about changing these things as we'll be discussing these things when we start our journey on AWS, right? So once we are done, we can simply scroll down and click on create distribution, right? So as you can see here, it may take some time to deploy this, but once we have this one deployed here, right, then we'll be getting the URL. As you can see, then we'll be getting the domain name, and whichever, now if we want to share this with anyone, we can simply share this domain name, and which will be hosting our static website, correct? So currently this is currently being deployed, that's why it is not visible. But again, once we deploy this will be our static website, and this will be opening up the same HTML page that we had defined as a static page for our website. All right.
Now, our agenda for today's session is we are going to talk about the Beanstalk, Elastic Beanstalk of AWS. It's a one of the service of AWS platform which is very much in demand. And apart from that, EC2 means first is the EC2 and the next is Elastic Beanstalk. So what is that? What it do? So I'm going to talk about that in a while. But yes, the Elastic Beanstalk is our first agenda. We are going to talk about the feature of the Beanstalk, then component of the Beanstalk, then architecture of the Beanstalk, and hands-on how to deploy any application on the Beanstalk. So this is our agenda for today's session. So let's begin. What is Beanstalk? Okay, even before jumping to the Beanstalk, I want to walk you through few things about the cloud. Why cloud? Why we move to the cloud? And actually cloud itself is divided into multiple categories. That is IaaS, PaaS and SaaS. Okay, IaaS, that stands for infrastructure as a service. PaaS, there's a PaaS, platform as a service. Then SaaS, that is software as a service. So we are having three different categories in which all our cloud is divided. So in short, we can say that our cloud have these three categories. Let's talk about that. So what is cloud? Okay, why we move to the cloud and what happens when we don't have a cloud with us? The very first thing is that we move to the cloud is, with the cloud we can focus more on the business, we can focus more on our say application side, just instead of working on the platform. How come? Basically, the major use of cloud, okay, when we don't have a cloud, no, at that point we have our on-prem solution. If we don't have a cloud, then we have our on-prem solution, that stands for on premises. But now we have the cloud with us. So what's the benefit of that? Now the benefit is that is like, guys, just take example, simple example, that you have one website. Okay, this is the number of users versus time graph. Number of users versus time graph. Now when we say that we have a number of users, so if we talk about a simple website, okay, in a normal website we have a trend in which users connect with us. We have one proper trend in which user connect with us. How come? Means if we talk about, like, say starting from a place where timing is in a morning, we are talking about, suppose 12 a.m. in the morning. We'll start with 12 a.m. in the morning till the 11 p.m. in the night, means a complete cycle. So at this point of time, we know that the traffic at the 12 a.m. is bit low, right? Then 1 a.m. again goes low. Then, so as the time will keep on increasing, the traffic is keep on decreasing till morning around say, I should draw a graph in different manner. I draw that in wrong manner. Just 1 second. Let me just draw once again. So will one axis, this is the user and this is the time graph. Okay. Now we start at 12 a.m. in the morning, in the midnight, I'll say. Okay. Now when the 12 a.m. in the morning, the users are very less. Then 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m. your traffic is quite low on the website. Suddenly at 7 a.m. the traffic start increasing and it keep on increasing around the day till the 9 or 10 p.m. your traffic is on the highest peak and again start decreasing after 10 p.m. and again come down to the lower point, right? So the trend is like that. In the midnight my traffic is low, and the, suppose I say 7 p.m. in the evening my traffic is quite high. 7 to 9 p.m. in the evening my traffic is quite high. Now suppose at this place we have a 10k users, and at this place we have only 1k users. At the very lowest point we have just a 1k users. So when I have to configure my application, I have to take this in the scenario that how much users can come to my website. Suppose I'll say I am going to manage all my design, I'm going to manage all my infrastructure. So for that particular place I have to take this thing in mind, that I can get the 10k users, right? Now because I have to take a margin of at least 2 more k, we'll say 12k users. I'll set up my infrastructure for 12k users, although still we having a 10k users. Now when the traffic is low, like in the on the say 3 a.m. or 4 a.m., when the traffic is low, still my capacity is 12k only, right? My capacity is 12k, but I'm getting only 1k users. Means my 11k capacity is getting waste, but I cannot do anything. I have to manage that. Why? Because if I'll not manage it, sometimes suddenly traffic increase, what I'll do? So in short, I have to take a margin, and this margin is a killing. Why? Because the price. When you set up this margin, obviously the price you are paying for that, and because of that price, your cost of the project will increase. And when the cost of the project will increase, ultimately your budget will goes out of your budget. So basically, when we set up our own system, there we have to go with this kind of the problem where we have this user management issue, because we have to set up our infrastructure in that way. Now, next thing, when we say I'm going on the cloud, okay, at the time when I'm going on the cloud, at that point of time, I don't have to worry, because there I am not the one who have to manage the things. Okay, there I'll not be the one who have to manage the things. Why so? Because how the cloud work, cloud is like a virtual. Okay, cloud is like a virtual. How virtual? Suppose tomorrow you want to use a Mac machine. Okay, I have a Mac machine. Now you have to test something on a Mac machine. You will say, Akash, I want to use a Mac machine, give me the access. What I will do, I'll give the remote access. Now with that remote access you can use that machine. Now, when you can use that machine with the remote access, it's my responsibility to provide everything to that machine. Means, suppose you need an internet, I have the one who have to provide the internet to that machine. I have to one who have to manage the hardware of that machine. Means, now your side you don't have to worry. How come? Because you are just getting the access to that particular system. You don't have to worry about how on the other side things are getting managed, how much costing is involved. Nothing you need to worry about. You just have to look into the your run your application, do the things. You don't have to work on any part of the configuration. You just have to work on the your application side. It says that when you take an application to the cloud, you can focus more 70% more on your business. How come? Because infrastructure side you don't have to worry, because that's a auto scaling model. Generally the cloud architecture work on the auto scaling model. Auto scaling means you will tell, just say, okay, I want to run this application, deploy that application over that. Now when you deploy that application, if the demand of the infrastructure increase, they will expand that server. If the demand of infrastructure decrease, they will compress their servers. Okay, so in short, we can say that we don't have to worry about the cloud for scaling, scale up, and scale down, and it's a very much cost effective, because we just have to work on our particular structure. We don't have to work on the infrastructure side, because once started, it's started. So that's what the cloud is, guys. That's what the virtual X of cloud is, and that is why these days everything is moving to the cloud. Now, guys, we have divided our cloud into three categories. One is IaaS. Let's talk about that important, because that's important to understand about the Beanstalk. IaaS, then PaaS, PaaS, then SaaS. We don't call it a SaaS. SaaS is SaaS. Ideally, we say SaaS. Okay. IaaS, PaaS, and SaaS. What are these? So basically, infrastructure as a service. I stand for infrastructure as a service. S stand for software as a service. P stand for platform as a service. Ideally, your cloud is divided into these three categories: infrastructure, software, or platform. What are they and how they are differ? Basically, when we say infrastructure as a service, here you are responsible for doing a lot of things. How come? What they do, when I say infrastructure as a service, no, at that point of time, you as a user will have given one platform. Like, just take an example, infrastructure service as example, that you are the one who bought a new laptop. Okay, now as you bought a new laptop, in that laptop, as a user, as a provider, what I'll do, I'll give you that laptop. Now you are responsible for doing everything. Means you are responsible to install a software, set up a database, means everything that you need to run the application, you will do. Okay, means you are the one who have to set up everything. As a user, we will provide you the infrastructure over which according to your requirement. Infrastructure means you say that we want to run one application that need 100 GB of the hard disk, 10 GB of the RAM, core to duo processor and window operating system. Now we will provide you everything in that terms. Okay, so when I say that you got the one platform over which you can run your application, means you are the one who have to configure everything with you. So you just get the infrastructure. That stands for infrastructure as a service. And from the AWS platform, what come under this? There's a one service called as EC2, Elastic Cloud Compute. EC2, Elastic Cloud Compute, is one of the service that come under the IaaS, Infrastructure as a Service. Now, PaaS, next thing. When we talk about the PaaS, Platform as Service, why we are talking about the Beanstalk here? Because we were talking about the PaaS, and in this PaaS, it come the Beanstalk. So, when we say PaaS, what do you mean by PaaS? PaaS means you as a user, you will get one platform. Now, what the Beanstalk do for us? As a PaaS means platform as a service. So in this category, you have to tell, suppose in this everything you have to set up. Suppose starting from the application in which you're gonna work on the say infrastructure or the software, everything you have to install. Just take one example. I have to run one Node application. Okay, just say Angular application. Now to run that Angular application, if I talk about this infrastructure as service, what I have to do is I have to install Node.js over that. But when we talk about this PaaS, or when we talk about particularly Elastic Beanstalk, what they do, what it actually do for us, that Beanstalk will help you to provide the platform. How they provide a platform? You tell that you want to run the Node.js application. Okay. Now, when you want to run the Node.js application over that as a platform, they will give you one structure. Although you have an option to configure that up to a great extent, means many people just know Beanstalk in the way that just bring the application deploy directly. No other configuration we can do. No, we can change everything of that platform also. But the benefit of using the Beanstalk over EC2 is the fast deployment. How come? The fast production. How come? Here they say that you will directly get one platform. Over that platform, you don't have to worry. Over that platform, you don't have to worry. You simply bring the application, put that over that platform. Okay. You bring the application, put that over that platform and run it. So here come the Beanstalk into the action when we talk about the platform. Okay. When you talk about software, they provide a software that you can directly use like a Salesforce, and you can run the application over that. So guys, why I'm talking about this thing? Because I have to come to the point, why Elastic Beanstalk? Why not any other platform? So here when we talk about the Beanstalk, now what is Beanstalk? AWS Beanstalk is a PaaS service used for deploying and scaling web applications and services deployed with Java, .NET, PHP, Node, Python, etc. on the familiar servers such as Apache, Nginx, Tomcat, and IaaS. What does it mean? It's saying that you will get the environment. Over that environment, you can bring the code and deploy the application. How exactly it look like? Okay, let's just have one look. We'll talk about it in detail in more. How exactly it look like? So we'll go back to our, this is our AWS console. Over this AWS console, if you look for a services, here it come under the category of compute. Okay, here it comes under the category of compute. Compute means where the processing happen. Now there is one service called Elastic Beanstalk. So in that Beanstalk, let's open that. They will ask you that which environment you want to set up. So if I say create one now, so I'll walk you through this platform in a while. Now, the main thing I'm showing you here is, see, it's saying me that which kind of platform you need. These are pre-configured. Some for Go, .NET, Java, Node, Ruby, Python, PHP, Tomcat. These are predefined platform, pre-configured platform. So over that, you just have to bring the application and deploy it. Now we have one scenario. We just discussed in this scenario. Option one, you can go to the Computerware and buy the component according to requirement and assemble them. Like you will set up everything of your own. That's a EC2. Or deploy an application without Elastic Beanstalk. That's what the first scenario. Second, you can visit the electronic retail shop and buy a computer that fits your requirement. The one I just showed you. Like if I have to run this over the EC2, I have to configure this platform. But here it say no need to worry about the platform. You just say which platform and upload your code. That's it. Means suppose you already have an application that is built in the Node.js or React or Angular or Python or Java or Ruby, any language. You don't have to do any pre-configuration. You will just pick this up and deploy it. Means just upload the code. That's it. Nothing more than that. Okay. Now, so that's a beanstalk. Now, I hope you understand, guys, what the beanstalk is. Okay. Now, as we are talking about the, see, those who are saying that I'm going to come to that or not, just to tell you guys that this is something PaaS. And talking about the PaaS is important here. Now, what all things we do here? Application and data, that's the only thing for a beanstalk we have to manage. Means your application and your database, these are the only two things you have to manage as a developer, as a user, as an end user, as a say DevOps. You just have to manage, or as an application owner I say, you just have to manage your application and data. Why application? Because obviously that's created by you and the database, and nothing more than that. These two things you have to manage. Now your runtime environment, middleware, operating system, virtualization, servers, storage, network, everything AWS will manage. Benefit, quicker deployment because I don't have to set up the things. Simplifies operations because obviously the infrastructure setup is a major task. Suppose when we take an application to production, no, as a DevOps, if I have to take an application to production, I'll take around 10 days to set up my infrastructures and test it, the say load testing, all those things I have to do on the infrastructure. Obviously when infrastructure is already provided to me, it's simplifies my operation. Cost effective, why? Because you don't need a lot of things to test on. You just have your infrastructure ready over which you can do a deployment, and ideally they provide us a very standard infrastructure that required for any application. But still it doesn't mean that when I say Node.js is the only Node.js I can do over that. No, although they give us a quite good amount of the customization option. They give us one standard structure, although they give us one standard structure that okay, for Node.js if you don't do anything you can do a standard structure, but ultimately you have option to configure more. Now obviously the cost effective because underlying things are ready, and multi-tenant architecture. Multi-tenant means when I talk about the tenancy means when we deploy the application, no, we have an option, are we going to take a shared tenancy or multiple tenancy. Tenancy means when the application is deployed, okay, so they suppose this is one server, okay, you say this is suppose 100 GB server, this server of 100 GB, okay. Now you just need a 5 GB, they will give you the 5 GB portion to you. Somebody need 80 GB, they give a 80 GB to them. So 85 consume, somebody in the rest 15, they will give 15 to them. Correct? So they divided that one server into three people. This is dividing is basically called shared tenancy. How come? How they divide? Like, have you ever done something like your hard disk is there, give one hard disk to one user, means one portion of hard disk to one user? Directly, it's not possible, guys. There's one thing called hypervisor. With the help of hypervisor, we do that part. But ultimately, they give a multi-tenancy, means they have an option either to go with a shared tenancy or a private tenancy. Now, when you say shared tenancy, in that case, your space will be allocated with all other people. When you say your dedicated tenancy, in that case, they will make one server, and that server is only configured for you. That's called as, say, dedicated tenancy. So Beanstalk will give both the tenancy, your dedicated as well as shared. And the last point is better user experience. User experience is better because of the multi-tenancy structure. Second thing, high availability and the auto scaling. Because of all these things, the user experience will be better, because as I said that if tomorrow the load will increase on the website, if the load will increase on the website, your infrastructure will become bigger. Automatically, it manages the load over that infrastructure. So that is how it make the better user experience. So quicker development, deployment, simplifies operation, cost effectiveness, multiple tenant architecture, and better user experience. Now, next. So web hosting platforms. So although this Beanstalk is not the only one, although apart from Beanstalk, we have OpenShift, we have Google App Engine, we have Sklingo, we also have our Python Anywhere, we have Elastic Beanstalk, Azure App Service, and many other. What are these platforms? These all platforms are the one, what they do is they directly help to deploy the application over them. They all provide us the platform. With that platform, we can directly, over that platform, I can directly run my application. So ultimately, there are multiple options available in the market apart from AWS. But why AWS? Because the most cost effective and the most high availability that is provided anything is Beanstalk. That is why Beanstalk is the most used service in the market when we talk about the any platform like this. Okay. Now, feature of Beanstalk. Elastic Beanstalk is the fastest and simplest way to deploy your application on AWS. As you already seen that, just select the platform, upload your code, and you are done. So just select the platform, upload your code, and you are done. Second, enable you to focus on writing the code rather spending time on managing and configure servers. All the things, nothing to be done. You just bring your code, focus just on the code, make the application functionalities better, because deployment will already happen. And when we talk about the continuous integration and deployment, no CI/CD work very well with this Beanstalk. So CI/CD work best with the Beanstalk because they give us a platform which is already ready. I can connect my Jenkins jobs, or I can connect my code commit of the AWS itself with this structure. So it becomes easy for us to manage it. Now, next, automatically scale your application up and down based on the specific need. I already explained this point that it helps you to scale up and scale down the application on the base of requirement, because here when it comes to the scale up and scale down, automatically you don't have to worry about that part, because these are some of the best things that AWS provides us. Now, give freedom to select the AWS resources like EC2 instance. They're optimal for our application. As I said that this is not the only thing that you can do. Although you see one platform, and those platform that you see is something like pre-configured, but we have the option where I can configure my platforms. How? Let me show you. Suppose you just select that you want to run a node application. Okay, you have a code, you can take a sample application, existing version, or upload your code directly. But you think like the infrastructure that is provided by this is not sufficient. Okay, is not sufficient. In that case, there is an option called configure more options. Open that. This is the place that very means a lot of people are not aware of this part, because for them they simply go, they select the server environment, they give the name, they select the platform and upload the code. Maximum people do like this. But point is, you have option to configure more. For many people, Elastic Beanstalk is just pre-configured thing, and they have just one thing, they can deploy the application over that. But when it comes to the configuration, lot of options. So let's see. Now, when I go to this configuration options, guys, now every single thing you can configure. The major point of the Beanstalk is, although you have a platform, but the best part is platform also can be modified. Means this is the edge of the Beanstalk. See here, when I say it's a platform and I have an option to configure this also. Now, suppose they say the software that we are using is Node.js version this, AWS X-ray disabled, rotate logs, log streaming, environment properties. These are the things. But you say, no, I don't want to go with something. They say, okay, you can modify it. When you modify, the server over which they are going to run the application is Nginx. You can select Apache also. The version of the Node.js, so many options to choose the version. By default, they go with the latest one, but you also have option to run that. And you can give the command. Means when the environment will start, at that point, if you want to give some command, you can give that also. So you can provide that command also by this. So this is the few things that is we can configure. Means first of all, when I talk about my software for a platform, by default the software is Node.js, but still I have option to change that software. Next thing is instance. By default, again, you have an option to choose the instance. By default, they will be the default instance, but you can select the disk type. Means volume. SSD, that's a solid state disk. If you think that the application that you're going to use is going to do so many input output operations, okay, when application is going to do so many input output operation, then at that time we'll go with the provision IOPS. Provision IOPS means input output structure. So those provision IOPS is used when you have a lot of input out operations, or you can go with the default, you can go with the magnetic or general purpose SSD. Then you have option to change the size. How many IOPS? So if I suppose I'll select this magnetic one, I have option to just size of that also. Minimum I have to go with the 8 GB, but maximum I can go with the lot of like 6558 GB that I can go with. But minimum I have to go with the 8 GB. Similarly for general purpose SSDs and IOPS, you can choose the number of input out operations also. In 1 second, how much input output operation you want it to perform. But we'll go with the default. Then you have security group. Either you can have your own security group, or either you can choose from the one you use for any other purpose. So these are some of the security group that you can configure. Okay. Then the next option is capacity. Now that was a volume. Now how much instances you are thinking, like by default it will just do a single instance, but you think like you sometimes have to scale up and scale down. Okay, sometimes you want it to scale and then scale down. Then in that scenario you can select the load balancer. The load balancer, when you choose the load balancer, there you can specify that minimum start with one instance and maximum go with 100 instance. Means if the load will increase, keep on adding the instance. If load will decrease, keep on reducing that instance. Okay, So on-demand instances. I want on-demand instance and I can increase or decrease on the basis of the demand that completely depend upon the your configuration type. By default, it go with the single instance. Okay. Then we say, see, the instances are also to multiple. So I'm not going deep inside that because that's the EC2 configurations, availability zones, placements. These all are the, I'll say, your different things. I don't want to go deep inside this because that's are more related to the EC2. Now, next thing, load balancer. If we select load balancer, then we have option to configure that. Then your rolling deployment. Now, what do you mean rolling deployment? Deploy all at once or immutable? Means what is deployed is deployed. You cannot change that. Rolling update or rolling means what the rolling update will do. Suppose I have one application. Okay, I took one application that is deployed over this application version A is deployed. Now, suppose you come up with the version B. Okay, when you're trying to deploy this application, until or unless this is completely tick marked, this is completely up and running, mean this version is completely up and running, this people will get only this version. It's more like unless or until the new deployment is not successful, unless or until the new deployment is not successful, old will not go. It doesn't mean that suppose you're deploying that. Okay, suppose you're deploying the application. Now at the time you're deploying the application, okay, now something got break, this application unable to deploy, some problem in this application side, right? If that is a case, then what happen, your old version will keep on running until or unless this will be 100% deployed. Okay, so that's a rolling deployment, means always update with the latest version, but it will wait for one version to get completely deployed. Next, security. When it comes to security, you have option to add the security group to this. You can add the multiple security group to this. And then monitoring, manage updates, notifications, network, database, and tags. In short, these are all the options that I can configure when I'm going with the EC2 instance. See, say these options are very on this part. By default, the free tier, a single instance. You want to go on spot, you want to go high available with spot and on demand or custom configurations. So all these options are available in the Elastic Beanstalk. So suppose, let me just show you the thing, then we'll talk about more theory. Now suppose I'll give a domain name. I'll say edureka.eu. This part. Okay, I'll check availability. It's this domain name is available. You have to give a domain name later on, right? Like if you say edureka dot, the URL will be edureka.eu-west. But if you later on when you take the application to live, you will link this domain name with your own original domain name. That's through a DNS. So that's how when you say akashhanda.me, it will come to this link because that we have to manage. By default, it will generate one URL for us. Now you can give the description of your platform. In the description, I'll say this is test node app. Now I want to create a one platform for the Node.js. It can be any. As of now, I don't have any code. I'll just take a sample application. The only difference is if I upload my code, you will see my code. If I simply take the sample application, use the sample application. That's the only difference. It is up to you. If you have already build code, make it into a zip or var file, upload it. Now simply say create the environment. It is going to take few minutes. In that few minutes, it is going to create one environment for us. See, this will take few minutes. So after a few minutes, we'll return back and this link, this is the link that is generated. If we go to this link, one default, your Node.js application will be running. One default Node.js application will be running in a while. So I'll ping you this link also. We'll come back later on after 5-10 minutes. This will be ready to use. I shared that to all of you, so we can check in a while. Although that's a major about the beanstalk. Now we'll just verify it's ready. I think it's not yet ready. We'll come back in a later and we'll just start talking about the fundamentals now. Next part is component of elastic beanstalk. Now what are the component of elastic beanstalk? An application is a collection of environment including environment, version, and environment configuration. Environment, version, and environment configurations. So an application in an elastic beanstalk is conceptually similar to a folder. So what they do is you just give them the folder, they'll run the application through that folder. So it's very similar to running the application over a local system, but instead of that, it's running over the cloud environment. Example, Tomcat web app. So we have Tomcat web app. So I can have web app that's having multiple environment to configure with that. If I go back and refresh this, see my environment is ready. I click on that, just refresh once again. Just click on that, you will see health okay. The one who's asking if I give a port number, in that case, what happened? In this case, your healthy check will not appear. Okay. So an application version refer to a specific label iterator of a deploy code for a web application. An application version point to an Amazon S3 object that contain a deployable code such as jar, Java jar, or var file. So we can directly pick those files and deploy that. So I have a code pipeline. With that code pipeline, I have connected my servers, and when the code will come up, it directly deployed over this servers. So see, it's showing me that a Tomcat is running version is this Tomcat web API. Every API is deployed on versions are deployed on the different servers. So environment with a beanstalk application house different running version of application. So I can have a different running versions of my same application also on that beanstalk. Tomcat web app and Tomcat web app production. So I can have a two different version. One is my development, one is my production. Now, so there are two types of the tires, web server tire or worker tire. Web server tires serve HTTP request and working tire background process the background task when we configure the environment. So Elastic Beanstalk report the health of web server. So basically you can see here it's showing me the environment is healthy. In case it generate all the logs, in case it's unhealthy, it mark it as unhealthy. So accordingly you come to know that application is working correctly or not. So environment is being updated past recent health check. So if the environment color is gray, it's like being updated. If it's green, it means, so what I'm talking about is this color, past recent health check. If it's yellow, failed one or more health check, and red, failed 3 or more health check. So by checking the color of this, you can check that what is the state of your environment. So gray, that you just made any change or you just have created that. Green, it passed all, ready to use. Yellow, failed one or more check, and red, failed 3 or more check. Okay. Now the architecture of Beanstalk is web server environment tire handle the HTTP request. It's more like Beanstalk environment, load balancer, auto scaling group, EC2 instance, host manager, and security group. So basically underline this Elastic Beanstalk. What they have, they anyways have one EC2. They have one EC2. Over that EC2, they have a security group layer. Then they have auto scaling layer. Over that layer, they have the Elastic Beanstalk. With that, sorry, this Elastic load balancer. This load balancer will divide the load into the multiple instances. Underline, it is launching one EC2 only. Suppose I'll show you. I launch one Elastic Beanstalk. If I go to my EC2, let me show you. If I go to my EC2, no, see, by default, one instance launched, right? By default, one instance get launched when I launch one Beanstalk. First of all, the bigger box is a Beanstalk environment. Next is a load balancer, which will give the CNAME and the route URL. Then you have an auto scaling group, which automatically scale up and scale down depending upon the requirement. Then you have the EC2 instances. Then you have the host manager, and you have a security group. So that is how your complete web server environment works. Now, what is worker? A worker is a process that handle background tasks during resource intensive or time intensive operations. So they launch a worker behind their task or application which try to handle the load and like email notification, generate report, clean up the database. These all are the worker that we configure. These workers help us to scale up my application or speed up my application. And why do we need worker? Your web server, one request come to that is a time taking. So we'll assign that to one worker who will do this task and other request got served. If we don't have a web worker between that, no, if next request will come, that have to wait for one request to get complete. Then only it can do that. So performance and request accept will be decreased a lot. But when your worker, when we request, is time intensive, it assigned to one worker and the worker will process. In a meanwhile, when a second request will come, we'll serve that request to the server. So that is how your workers work, and we have to configure those workers. So if we go back to environment, so we are getting the web app servers that have the workers that help to achieve this functionality. Now, how this environment communicate? So we have web server environment. There we have one thing called Route 53. Route 53. This Route 53 is giving the URL. We use a queue services, SQS. SQS, that stand for your queue service. So what that queue service will do, whatever request you assign, okay, the simple queue service, what it do is whatever request you assign, it put in the queue. If they have a time to resolve that, they will resolve it, else it kept in the queue. So it keep in the queue, and every time it retry to that sending that request, else it keep in that queue until it receive. How it work? Just take simple example of your WhatsApp. What happened in WhatsApp? You send a one message. Suppose other person whom you have sent the message is not right now having the active internet. Okay, not having the active internet. If they don't have the active internet, what happen? That message get only one tick mark. At the time when it get one tick mark, where is it this message is? Ideally, at that point, that message is inside the queue. So that message is inside the queue. Once you will able to say other person is active, that message is received. So that is how your queue service also works. So we have client talk to web server pass a request to the queue send a message to the HTTP post worker, and it respond back. So let's see a demo for how to deploy the application over the Elastic Beanstalk. So guys, this is how your Beanstalk work, and that's what all about the Beanstalk. See guys, my application is active now. If I go to this, see one node application is running over that Beanstalk. You guys can also try by hitting this URL. So this is how your Beanstalk work, and that's what all about the Beanstalk. So VPC is something guys is very important topic of AWS. In that VPC particularly, I can say if you are planning for any kind of interview and so no, so 40% of your weightage is actually coming from the VPC. So VPC is a super important topic that we should learn. What is VPC? See, the complete cloud that we have, the complete cloud environment is basically called public cloud, right? Then what exactly the VPC is? VPC stand for virtual private cloud, means over that public cloud, when you get a space as a private, means some companies say that we cannot go for a public cloud because all data are shared. We say no worries, you don't want to go with a public cloud, we'll give a separate space of your own. That complete space will be of your own, and over that space you can run that application. So in short, we can say that over that public cloud, when we get a space as a private space, that's referred as your VPC. VPC stand for virtual private cloud, in which we'll get an isolated space from the complete cloud. No one else can go to my space and configure that. So it's a very important topic called VPC. Now, VPC is logically isolated from the other network. In AWS cloud, we can launch AWS resource. I'll show you how to configure VPC completely. It gives all the benefit of traditional network that you can have of your own data center. Access the resources and application through IPv4 and IPv6 on your VPC. Give the better scalability infrastructure in the AWS environment. You will complete control over the network. The best part is we have a complete control over the network when we go with the VPC. As we know, it's an isolated space. For a more secure environment, we make a space. Okay, let me show you one architect diagram for that. Now, VPC is something very important to learn how to configure that. How exactly we configure the VPC is, VPC contains some components, guys. Okay, VPC have a lot of components that we configure. What are the components in VPC? The very first thing in VPC is basically called as Internet Gateway. Internet Gateway is something. So this green box, consider this green box as one VPC. Okay, to this VPC is an isolated space. It cannot talk to internet. Guys, this VPC cannot talk to internet. To make the VPC to talk to internet, we actually have to give one thing called Internet Gateway. Internet Gateway is the one that help you to make this particular VPC to talk to internet. Else, your VPC is a complete isolated space on the AWS cloud that cannot talk to internet. Now, in the VPC, there are some important part, that is one public cloud, one private. When we don't have a cloud, we call them as subnets. This is one space. Okay, this is one bigger space. In this space, we divide that into small parts. Why we divide them into small parts? Basically, the reason for dividing them small parts so that we can run multiple things over this area. So that we can run multiple things over this environment. We create a one secure environment. Over that secure environment, we'll set up this particularly your subnet. Subnets are more or less like that, a small areas inside the VPC over which we launch the application. How many subnet one VPC can have? Guys, one VPC can have multiple subnet that depend upon the CIDR value. What is CIDR value? I'll show you. Basically, the way to get the IP address to VPC. On the base of IP address, we'll get that how many subnet I can launch in one VPC. So in one VPC, I can have multiple subnets. Subnets are the spaces. Now, ultimately, the point is like that. So we have the subnet. In each subnet, guys, we can put different things. Some subnet are the public subnet. Some subnet are the private subnet. Okay. So public subnets are those that basically available to the internet. So what we do, we divide our application into two categories. We'll say we have some part we'll put a public, some part we put private. All the things that we want to access over the internet. As an example, suppose in one application we have application and database, right? Database is something a secure part. We don't want to make it available outside. So things that we don't want to make it available outside, we'll put them into the private subnet, and the things that we want to make it available outside, we do the public subnet. What component VPC have? VPC have one complete box called VPC. To connect to internet, they have an internet gateway. We have that divided into the small subnet. Each complete your VPC divided into small subnet. In that subnet, we have some public subnet and then private subnet. In the public subnet, we have the application that actually run over my front-end application. See, it's never happened to you that you are able to access the database of Facebook, right? We never access the database of Facebook, but we're able to access the application of Facebook. So what they do, something they put in a public, something they will put in private. So how we decide any of my subnet is public or private? That depend upon one more component in VPC called route tables. Route tables. What is the route table? Route table is a place where we keep the entries of this particularly your subnets. All the subnets get added into the route table. Okay, all the subnet got added into the route table. So the point is very simple, that we have one default. What is this black box? This is called default route table. Every VPC have one default route table. All the subnet that you launch, suppose I have 50 subnet in my VPC, all the subnet that you launch will be a part of this route table by default. First of all, everything will go in the black box. Okay, your subnets also, your internet gateway also. Now when everything is a part of black box, what happen? Now I want to make something which cannot access over internet, but here if you see, as everything a part of same place, this internet gateway is also same place. So anyone who is accessing my VPC come to this route table, they can know the IP of this also and IP address of this also. So they can access all the things from my place, right? There's no use of creating a different public and private. So to overcome this problem, we got one solution called different route tables. We'll create different route tables are something where we insert the record, where we insert the IP address of each subnet. Now after that, what happened? We have public subnet, private subnet. We make a public route table and a private route table. All the things that we want to expose to public, we'll put a public route table, and internet gateway is connected to public route table. Whereas the thing which I don't want to expose to internet, I'll just keep in a private route table. All the new subnets you launch, all the new subnets will keep entering in a default route table. And whenever you want, you can move from default to public, or you can move from default to private. One in subnet can be either a part of public route table, private route table, and by default they're a part of default route table, but you can move it from this place to their own respective route table. Internet gateway is connected to public route table. Now what happens when somebody accessing the internet, they can access my public instances. And how private instances work? Your public instance can talk to the private internally. They can communicate, means you look for some data, your application will actually talk to the public subnet, your public subnet will talk to a private subnet, and from private subnet we can access the database. Generally database we keep in a private and the application we keep in the public. What is this NAT? NAT actually refer to, guys, what happened? I have this suppose setup created, right? Now the requirement come up on the other side that whenever this database is configured, no, now this database sometime want to talk to internet, but in this configuration my database cannot talk to internet. Neither I can talk to the database, neither database can talk to internet. When both things got stuck, that neither you, neither from the internet I can talk, neither database can talk to internet. In both this scenario, you have a problem. Suppose you want to download something new. Suppose I got some new patch for database. How I'll do? So guys, we introduce one thing called NAT. NAT refer to proxy. Okay, NAT actually refer to proxy server. So basically, what happened? Now it will be a one-way communication. How one-way communication? Your database will talk to the NAT, and NAT through route table talking to internet. Only one-way communication. From private I can access internet, but no one from outside can access your database. That is called as, guys, NAT gateway. It's called a proxy server. Basically when we have to access a content from database to the outside network, we use a NAT gateway, but still I cannot access the private through internet. Private can only access through the public. I'll give a quick revision over that once again. Internet gateway is the one that helps to connect to internet. Subnets, in one VPC we can have multiple subnet. How to decide, I'll show you in a minute. After that, basically what you do is you divide that into public and private depending upon your requirement. You can have multiple public, multiple private. After that we have a route tables. All the entry of your subnets will be a part of a route tables. We can have public route table and the private route table and the default route table. All the new subnet that launch is always a part of default route table, and later on we can move to public or private. Internet gateway is connected to the public route table so that it can access the instances over the internet, and public subnet can talk to the private subnet. If a private subnet want to access the internet through NAT gateway, they can talk to the internet. In short, I can say that this complete design is basically referred as, guys, VPC. I'll show you the configuration, how to do all these things. NAT. NAT is something, as is private cannot access internet. Sometimes what happens, we have to require the internet at private. So private can use the NAT gateway like a proxy server. With a proxy server, private can access the internet, but no one from outside can access this private. Now, route table is something where we insert, we keep entry. Sorry, sir, we don't say nets, subnets, so that we know what are the subnets that can access internet, what subnet should not, what's the net that can everywhere in the real time. Whenever we use this private environment, we use a NAT gateway. Now let me show you how many subnet we can launch in one internet. So let me open one document. The one thing called CIDR. What is CIDR? Class inter-domain routing. CIDR is the one that will decide how many subnet you can launch in one machine. To know how many subnet we can launch into one machine, in the CIDR have some value. There are two range of IP, IPv4 and IPv6. That depends on which range of IP you are using. How many subnet I can launch in one VPC means how many subnet I can launch, and inside the subnet how many instances we can launch. How many subnet you can launch, that defined from total IP range of 32-bit. The total IP range of this is 32-bit. Okay. Now out of that 32-bit, basically what happened, you can choose between 16 to 28. The value number will be 16 to 28 you will choose. Now what they do, suppose I choose a CIDR value as 16. If I choose CIDR value as 16, then what it will do, no, 32 minus 16, that is 16. Put 2 raised to the power 16, 2 raised to the power 16, and it will become out to be 65536. What does it mean? It means that this many subnet I can launch in one VPC if my CIDR value is 16. CIDR is a range you have to select. I say if my CIDR value is 16, I can launch 65536 subnets. How? 32 minus 16 is 16. 2 raised to the power 16 is 65536. Then suppose my CIDR value is any between 16, 17, 18, 19, 20, anything. Suppose my CIDR value is 24. If the CIDR value is 24, then you will say 32 minus 16, 8. 2 raised to the power 8 is 256. Similarly here 32 minus 28 is 4. 2 raised to 4 is 16. Means minimum 16 subnet and maximum 65536 subnet we can launch inside one VPC. So that depends upon a requirement. If a requirement is of more subnet, choose the lower CIDR value. If a requirement is of a higher subnets, choose a lower subnet value. Means if a subnet value is lower like 16, you can launch more subnet, 17 more subnet, like that. If your value is 28, you can launch only 16 subnet in one VPC. So that completely depend upon. And generally we try to choose a lower, higher value like 24, 26, 27, like that. Because if we use say something, no, in terms of 16, we get so many. In a practical I'll use this only, but if we use the 16, what happen, we'll get so many subnet IPs, so it's a more chance to hack. Generally we try to choose a value as 28, 27, 26. That depend upon my CIDR. As an architect, you are responsible for knowing how many basically subnets I should launch, so that calls CIDR. What happened to other IPs? So I choose, suppose my CIDR value is 16. In that I can launch 65536 subnets, and inside the subnet, guys, we can launch our machines. So the one diagram that we just understand, we do this diagram by practical now. These are some steps that we have to follow. How? Step to create VPC, launch subnet, create route table, create internet gateway, then set attach internet gateway, add subnet to the route table. Step 2, associate internet gateway, launch instances in the subnet. Step 2, connect with the instances. Step 2, connect the public with private instances. Step 2, integrate the NAT gateway. So all these steps are very clearly written here. There's a number of IPs we will get. Means this many IPs I can launch, random IPs. How IP selected, I'll show you. Let's go back. Let's just configure each and everything now, one by one. I'll go to AWS. So here we'll just create AWS. I'll go to AWS Management Console. So let me just log into one of my account. So I'll log into one account. Okay. Now in the services, there's one thing called network. In networking, we have VPC. We'll go to this. We'll start your configuration. We'll click on your VPC. So it's written every step. First of all, go to your VPC, create VPC. So we'll go to your VPC, create VPC here. By default, every account have one default VPC. We should not delete the default VPC. In each region, we have one default VPC always. Give some name to that. I'll say edu VPC, any name, Edureka VPC. See, it asking me the CIDR value. I'll say 10.0.0.16. I'm choosing a CIDR value as 16. You can choose any CIDR value. And create. And create. So what it did, it has created one VPC for me. What it did, according to diagram, we'll open a diagram also parallelly. It has created this green box. And in this green box, by default, you'll get this route table. Let me show you. Now, there was an option called route table. We'll go there. By default, one route table will be created for you. Let's see. That one for default VPC, one for RVPC. How to know which is for RVPC? RVPC number is 028 AFC, right? It attached to this one. So this is our route table. We'll say it default route, default RT. So I created one VPC. While creating VPC, we got one default route table. Okay, we got one default route table. Next step. So this is created and one default route table is there with us. Next, launch a subnet inside that VPC. Now inside the VPC, we can launch a subnets. One thing called subnet. I'm going to create two subnet, one public, one private. Create subnet. Name. I'll say private subnet. In which VPC? I want to create in my VPC which I created. Any availability zone. I choose any availability zone and CIDR value. CIDR value for should be between your range. The value you have choose for a main VPC, it should be in a range. So I write 10.0.0.0/16. So it should be in a range. I say 10.0.10.0/24. You can use other IP also, but it should be in your IP range. This is for my, I make it a public first of all. This is my public. And we'll create one for private. One for private. That is 10.0.2.0/24. That's my private subnet. So I create two subnet, one public subnet, one private subnet. All the question I'll take at the end now. We just focus on concentration on configuration. So ultimately we created two subnet, guys, one public, one private. CIDRs should be unique. All subnet enter in the route table. So now We create two subnet. By default, I told you all subnet will be a part of route table. How I can see that? See, in the route table, if you go to subnet association, see, do you see two subnets? By default, when we create the subnet, no, all subnet default get added to this default route table. First of all, there's no public subnet, no private subnet. They are in a one place. That's my default route table. We'll create a separate route table, one for public route table, one for private route table. Create route table. I create one public RT in my VPC and one private RT in my VPC. Public RT and private RT. The two RT we created. Right now they are not having any instance. So till now what we did, let's understand. We created this big green box. We launched two subnets. We have by default one route table and we created two route table, public route table and private route table. Now what we'll do is public subnet will put in a public route table, private subnet will put a private route table. Can we have duplicate record? No. One subnet can be in any one route table. Now how we'll do that? So let's attach that first of all. Open your private route table. There's one thing called edit subnet association. Click on that. It shows you what subnets you have. In a private route table, I add a private subnet. Similarly, in public route table, I'll add the public subnet. After that, if you check a default route table, now default route table have no subnet because when we move to public route table, when we move to private route table. So what we did till now, public into public route table, private into private route table. Now next step, internet gateway. Now you have to launch our internet gateway to connect to your VPC. We'll go back and talk to internet gateway. I'll say edu IG, any name I can give. I'll create one internet gateway. Now created. After that, attach the internet gateway to VPC. How we'll do? Select the internet gateway, click connection, attach to VPC, select your VPC and attach. So ultimately, I have attached the internet gateway to VPC. So now internet gateway is attached to my VPC. Add subnet to route table. So we already added subnet to the particular route table. Then associate IG. In which route table should I attach the IG? Public route table. Why? Because public is something that can have to access over the internet. Now public route table, I'll go. We add the subnet. Now go to route. In the route, edit. Add route. Say 00 means from anywhere I can access my subnet VPC. What you want to attach? Internet gateway. Select and the name of internet gateway. Now save it. You have attached the internet gateway and added that internet gateway to public route table. Till now guys, this structure is ready. Our two subnets are there. We have our route tables. We have our internet gateway. All of them are attached. Now we'll start using that. VPC is created. Now we start using that. We try to launch the instances in the particular subnet one by one. How? Let's open a one more tab. We'll go to EC2. Here we'll say running instances. In that running instances, I'll start a two Linux instance. Launch. I'll launch one Amazon Linux with default configuration. Here in the configuration instance, I'll choose a VPC. I'll launch inside my VPC and see it show me a public VPC have 251 IPs because we choose a CIDR value as 24. 32 minus 24 is 8. 2 raised to 8 is 256. So we get total 251 IPs. I told you total is 256. In short, we get 251 IPs for this instance. Right now, I launch a public one, public subnet. So I'll give the public IP to that. and rest is fine. Rest, I'll add the security group, that is HTTP and HTTPS. Launch. So particularly I have launched one EC2 instance inside the public subnet. So we have launched one instance inside the public subnet. Now similarly, we launch one instance inside the private subnet. We'll select next. This time private subnet. So choose your VPC. See, so I'll go to private and public IP will disable for this. Storage, configuration, HTTP and HTTPS. Review and launch. So guys, I've launched two instances, one in public, one in private. So let's go back. Now they got one public IP, but if I check the private IP of this one, no, see, private IP is between our range. You see, 10.0.1.238. Private IP will be in the range of our CIDR value. See, public IP can be anything, but private IP will be in our range for this also, as well as for this one also. See, you show me in a private one, you have 10.0.2. In the public one, you have 10.0.1. So guys, I got two instances, one public, one private, and kind of except NAT gateway, these are available. Now we'll try to first of all access the public subnet, means public EC2 through internet. We'll see, can we access the public through the internet? And then we'll see, can we access private through internet? You have to make it running. Once it's ready, then we can do that. Then we'll do a NAT also. We'll see why we need a NAT. Now guys, our instance are ready. Let's try. This is my public instance, right? So we'll just rename them. The public one, I'll say public EC2, public EC2, and I'll name them as private EC2. First of all, see the public EC2. The public EC2 or public IP, so we can connect with that. Whereas private EC2 don't have IP. How I can gonna connect with a private IP? Obviously, I cannot connect over the internet. It's very simple. I cannot connect through internet because they don't have any public IP. Now, first of all, we'll try to the public subnet, public EC2 instance. How? Click on connect, choose this SSH. To this temp file, you can directly run this command. CD download. So, guys, I have connected to my public EC2. See, 10.0.1.238. Whose IP is this? Your public EC2. I'm able to connect to my public EC2. And if I write here ping google.com, see, let's wait for a minute. See, it's able to ping that because from my public subnet, I can access the internet. Why? Because it is connected to internet gateway. Now I'll show you one thing. We'll go back and remove the internet gateway from the public route table. Let's try. We'll go back to our public route table. We'll edit and we delete this internet gateway, suppose. Now, once I delete the internet gateway, let's try to ping again. Also, let's try to connect again. Internet gateway is not connected now. Okay. So we'll go to my folder. See guys, I'm not even able to connect to that instance. Why? Because it's in a closed environment by VPC. As it's a part of VPC, nobody from outside can access that. The reason for that is because you have not connected with the internet gateway. To talk to the VPC, you must connect to the internet gateway. I'll go back and again connect my public route table to internet gateway. So that I told you that it's a private network. You make a one private cloud over your public cloud. I add an internet gateway now. Save. Now go back and again try. See, able to connect. So as I told you, to talk to the VPC, you need to have one internet gateway with you. Okay. Now, next step, as my private instance don't have public IP, how to connect to private? I told you private cannot access over internet. Then through public, I can access private. How? Through my public one, I will able to access the private instances. So what I have to do is for this, first of all, go to the public one. Now to connect to the private, you need a PEM file by default key. Here no, I'll make a one PEM file. I'll take a sudo access, sudo su minus, and I write vi my dot pem, any PEM file name you can give. Just create one PEM file. Which PEM file? Which you choose. So it's by name of Amazon Singapore. I have to go to my folder, open that file, copy the code and paste it there. So I'll search Amazon Singapore. I will edit this file. Why I'm doing that? Because public can access private. So in a public, no, I'm creating one PEM file and then I'll try to access the public from private, basically from a public. Private cannot access directly. Through public, I can access private. And that's what I'm trying to do now. I'll take this key. This key, I'll paste it here. I'll save this key in the. Now what I did, guys, in my public, I created one PEM file. Okay. Now go back to the EC2 again. We'll click and connect. Now the public IP, the private IP. So we'll try to connect through a private IP. Through public, what we are doing here? Through public, we are trying to access private. Okay. So I'll write this and I'll give the PEM file which I've created. It is my.pem. See guys, I'm able to access my private through public. My private through public. But if private try to access internet, then ping google.com. Why we are not there? Is not able to log into private one. It's a one only. It should be two. So basically, you have to give permission to the file. The PEM file you have created, you have to give permission. Chmod 400. All steps are there as well. Now you are in a private instance. See. Now try to ping Google from here. From private, I'm trying to access the internet. See guys, I will not get any response from Google because from private, I told you, from private, you cannot access the internet. From private, we cannot access internet. What should we do for that? NAT. Let's introduce the NAT. How we do that? It's a create a NAT gateway. How we do that? Now subnet, you should choose your subnet. So your NAT gateway will be launched inside public subnet. So we'll choose a public subnet and I assign an IP to that and create. So I did a NAT gateway, guys. But NAT gateway add in a private route table. Created in the public, added in the private. So let's go back. Go to private route table, route, edit, add 0.0.0.0./0 NAT gateway, save it. Now once this NAT gateway got created, it'll take some time to get a NAT gateway. Once this NAT gateway is created, your private can access the internet. You cannot access internet and internet cannot access private, but from private I can access internet. That's what I told you. Through this, with NAT gateway, I can access internet, but no one can access a private. So guys, we configure each and everything. Once that NAT gateway is ready, we'll see that from private I will to access the internet, but no one from outside can access the NAT gateway. This is the complete setup of VPC that we just did. Now let's see, my NAT gate is ready. It's available. Go to that. See guys, already started pinging. See, how come? Basically because now through NAT gateway I'm able to access that. How to stop that VPC? You configure that. Now how to stop? You cannot go and directly delete a VPC directly. So you have to do step by step. How to stop? First of all, go to EC2 and terminate this EC2 first of all. Delete this EC2. Very first step. Terminate both the EC2. Instances stopped. Next step. Go to your instance here. Now, first of all, you cannot delete this internet gateway or NAT gateway. You should go to route table first. From route table, disassociate all the things first of all. Open route table, subnet association, edit, remove that. Similarly, in the routes, edit, remove the internet gateway. First of all, remove the things one by one. From route, first of all, delete the instances, then remove from route table. Then subnet, edit, disassociate that. Now all of them are free. Now I can delete public and private, both route table I can delete. Delete it. Now internet gateway, first of all detach it. Detach. It's somewhere showing attached. Go to NAT gateway. Delete that. NAT gateway deleting. Route table deleted. Subnet. Subnets, you can select a subnet and delete the subnet. Both subnet deleted. Why not public one? I think with this something is associated. Now simply go to VPC, try deleting VPC directly. Select and delete that. So delete my route table also, internet gateway also, default route table also. So guys, your VPC is completely removed. All the subnet, your route table, internet gateway, and NAT.
So the main agenda for today's session is we are going to discuss on the compute domain offered by AWS, why we have to use AWS Lambda, what exactly it is, what are different available SDKs, and how we can use Lambda with the Eclipse IDE. And we'll be looking at a small hands-on on using Lambda function, going further step by step. So first of all, if we talk about the computation service, then AWS, as you know, is one of the not just one of the, but it is the leading global leading cloud computing platform in the entire globe, followed by Microsoft Azure and then GCP. So AWS started back in 2006, and since then it has been the leading platform for cloud computing, where it offers more than 150 plus services as of now, which ranges from IoT, blockchain, from the computation services, database services, storage services, on multiple AR, VR, on gaming, on IoT. So there are multiple components on which AWS is providing the services. The total number is more than 150 plus. And they all are completely structured over the cloud platforms. That means we don't have to worry about provisioning any service. If we have an application, we can directly choose the configuration of servers that we need, and then we can get our application deployed on top of AWS resources. Same way we can have the entire storage services based on category, based on usage that we can get started with. And AWS has multiple domains, multiple categories of services. One of them is the computation services. So these are main three services offered by AWS in terms of computation. First of all, we have AWS EC2. So basically, EC2 is like a virtual cloud service. It's like a virtual server. Let's say when we are trying to deploy the application, obviously that application needs a server. Without a server, it cannot run, correct? So same way, EC2 is a virtual server that we can deploy like a virtual machine where we can choose our own number of cores, the amount of RAM, we can choose the image as a base operating system, we can choose a storage type, we can choose its capacity, we can choose the type, and then the tenancy, we can choose every parameter, and then we can deploy these virtual servers as a part of EC2 service model. So we were discussing on the computation services offered by AWS. So EC2 is like a full-fledged service offered by AWS through which we can deploy multiple virtual servers. Like we have virtual machine. Now, whenever we are deploying any applications, we need a virtual machine where we can define the number of cores, the amount of RAM we need, the amount of storage we need, the type of storage, the type of operating system, any base AMIs, or we can say images, the type of keys we are going to use, and the type of access level in terms of networking and security. That means we can define every kind. That means we can define every kind of parameter by using the concept of virtual machine, and then we can start deploying it for hosting our web application. That is what EC2 is all about. EC2 refers to Elastic Cloud Compute. Then we have Beanstalk. So using Beanstalk, we don't have to worry about launching the VMs at our own end. We only have, so, and that's why this is mostly used by developers. So being a developer, if you're working on any code on Node.js, on Java, on PHP, now we know that if we have a dynamic website and if we have a PHP based code, now we want to deploy it on the servers. That means before deployment of that code on the servers, we do need to set up the environment first. That means we do need to configure the PHP servers. We do need to provision the entire EC2 servers, and then only we can get started, correct? Whereas in Beanstalk, we simply have to upload our entire code, and then we can let the code being executed one by one. That means we don't have to worry about provisioning of servers or installation of entire servers. We can choose the entire environment. For example, if we have a Node.js application, we can choose Node.js environment, and then we can directly upload a code and have it deployed. And that's the ease that we get with Beanstalk. And then we have Lambda. So Lambda is basically a serverless computing platform. For example, let's say when we are building our website, let's understand a simple use case of Lambda. Let's go back to our notepad. And when we talk about serverless computing platform, for example, let's say when we have a website, let's understand a real-time use case. We have a travel-based website. We have a travel-based website, and now in that travel-based website, we have developed a chatbot which asks the users their preferences, or if they are looking to book a flight ticket, then it automatically gets all the responses, and then it transfers the same detail back to the sales team, or it generates a ticket automatically. So what we can do is, now if we have a chatbot where we are asking the users for the responses, for example, we have asked them, okay, where they would like to go. They have responded with a city name. Then we have asked them how many passengers, at what day, at what time, which airline they would like to prefer, any food preferences, any seat preferences. And now once they have entered each and everything, then we want this entire piece of information to be sent either to the sales team, or we want them to be transferred to the CRM, or we want it to be processed, and then it has to be sent to the let's say a ticket management system, so that based on whatever responses they have recorded, we can generate a ticket, and then we can send the ticket along with the payment link as well. Correct? So here we can choose. Now for this entire use case, we need a processing system. We need to process the piece of information, and then we have to deliver it, correct? So there are two ways of doing that. Either we can go ahead and deploy a full-fledged server, that is EC2. We can deploy a full-fledged server for EC2, and then we can process the request from EC2. But when we are deploying EC2, we have to deploy it by each and every component. That means we have to define the image type, the instance type. We have to configure the entire options for provisioning of servers. We have to choose the storage, the key. We have to do everything, correct? Whereas, and EC2, as you know, is built on an hourly or second basis. For example, let's say we had deployed the EC2 instance, then we are built on the terms of every hour or every second, depending upon the instance type that we have deployed, correct? And the moment our servers are on and we have to pay for the entire durations our servers have been up and running, even though they have been idle, but as long as they are running, we have to pay for it. And for example, suppose if processing this entire request takes only 10 seconds, and we are processing only 5 requests or we can say every hour. Now using the chatbot, we are processing only 5 requests every hour, and a single request, let's say it takes up to 10 seconds, right? That means in every hour we have a requirement of computation of how much time? Only 50 seconds we need to process in complete hour. That means if we keep our EC2 instance idle, then just for processing requests for just 50 seconds, we need to pay for a complete 1 hour of idle time for EC2, correct? That means now that means that's the another way of handling the entire processing request by using the service named as Lambda. So this is a symbol for Lambda. So using Lambda, we can have the entire processing done. So Lambda is basically a serverless computing platform. When we say serverless, it does not mean that there are no servers here. Obviously, the processing has to be done through servers. But here we don't have the requirement of deploying the servers at our own end. We can have the entire services deployed, or we can say taken care by Lambda itself. And then we can simply use Lambda to process the computation request. And suppose that if the request was processed only for 5.4 seconds, that means we have to pay only for 5.4 seconds, nothing less, nothing more than that. If the entire request, if we have the entire request being processed for suppose 3.2 seconds, that means we have to pay only for 3.2 seconds, nothing less, nothing more, because here the billing for Lambda works on every subsecond. That means the billing threshold is only for 100 milliseconds. For every 100 milliseconds, we have to pay for it. So that's how it becomes a much better, much easier, and much more efficient manner in which we can have this kind of processing done by using the serverless computing platform, that is Lambda. Now, why AWS Lambda? So Lambda is basically an automated version of EC2 where we don't have to worry about the entire architecture. That means we don't have to worry about provisioning of the entire EC2 service. We have the entire services taken care by AWS itself. And then now all the background tasks, all the deployments, security parameters, they all are taken care by AWS itself. And that's why Lambda is treated like a serverless computing platform, meaning that the developers, they don't have to worry about which AWS resource to launch or how will they manage them. Being a developer, we only have to worry about uploading our code to Lambda and then simply running it. That's it. We don't have to worry about any other component when we are working on it. And Lambda is also offered as multiple SDKs as well. So Lambda is also supported, right? Lambda is also supported by multiple SDKs. SDKs as in software development kits. For example, let's say when we want to use Lambda, then we don't have to even come out of our development environment. We can directly use the toolkits offered by both by Lambda and as well as by, let's suppose if you want to use Lambda or Beanstalk, then we have a toolkit available. That means we can install the toolkit for Eclipse, for Visual Studio Code, and then we can get started automatically. That's the ease which we get by using AWS Lambda services. So we can use both. We can use the SDKs available for Eclipse and as well as for Visual Studio Code as well. All right, so first of all, let's see how the entire Lambda works and how we can create a function out of it and how we can launch it. Now, first of all, let's see how the entire Lambda service is structured. And there are multiple IDs that we can use in order to get started. Like we have Eclipse. We also have Eclipse. We also have Visual Studio Code as well. So we have SDKs available for both. If we want to use any of these, we can get started. For example, and then we have Eclipse as one of the most popular ID. We have Visual Studio, and then we have Eclipse. So now we have the IDs available, like we have Eclipse, we have IntelliJ, we have Visual Studio. So the SDK for AWS is available for both Eclipse and for Visual Studio as well. So we can use any of these to get started. So first of all, before we can get started, we have to create the Lambda function. Now, a simple use case is, let's say we have a Node.js application, we have a PHP-based application. Then we can choose the entire runtime environment in which we want the entire code to be deployed. For example, here we have support from .NET, .Go, Java, Node.js, Python, Ruby. We have Python 3.7 to Python 3.8 as well, 2.7 as well. So we have multiple runtimes supported by Lambda function that we can create and now, right? So basically here we are going to create a complete, now there are three main options through which we can create the Lambda function. We can author from scratch. That means we can create the entire function at our site, at our own end. We can use a blueprint as in a base code. That means these are templates for different applications out there. Like we have for Kinesis as a part of data analytical platforms. We have the echo command based on Python. We have multiple microservices based. For example, if we are trying to develop a simple chatbot, then we have the blueprint for Lex. Lex is a chatbot system service offered by AWS through which we can get started. So that's how these are different platforms that we can, or we can see these are different blueprints that we can launch as a part of its entire program set here. So these are now based on the entire blueprint here, we can choose accordingly, or we can browse the entire serverless app repository, which we can browse through. For example, if we have the requirement for the entire application, there's already built, just like we have a GitHub community where we get multiple source code that has been submitted by different developers out there. So we have the entire public application repository that we can choose from, or if you want to get started, then we can choose author from scratch. Now, once we are now, let's suppose as our use case, now what we are trying to achieve is, as a use case, we can simply choose, okay, we want to author from scratch. Then we can start author from scratch as well. Let's say as a part of a use case, let's do one thing. Let's create a simple Lambda function. Now, S3 is an object storage service offered by AWS, right? So now what we want, whenever we are adding any object in S3, S3 is simple storage service offered by AWS. We want that whenever we are adding any object in S3, we should be that particular object addition, this event should be processed by Lambda. Whenever we are adding any object, this entire event should be processed by Lambda, and then we should be receiving an email stating that something an object has been added into our bucket so that we can take necessary actions. So again, this is also an event-based process request. Whenever we are adding any object into our S3 bucket, we want the entire event should be processed by Lambda service, and then it should be sending out an email through which we should be getting notified if anything has to be added here. All right. So now we can erase this up. We have an S3 bucket, and now we want to make sure that whenever any object is added to S3, that particular event should be processed via Lambda, and then we should be receiving an email by this entire Lambda function. This is something that we are going to achieve as a part of our hands-on. So before we can achieve this, we have to create a function first. So for creating that function, we can come down to our Lambda service. Now here, first of all, we have to create the functions and all. We can start from scratch. We can choose the Lambda function and then we can start from scratch. That means we want to start from scratch itself. Just a moment. So first of all, we have to search for Lambda. We can click on create function. We can author from scratch. Let's give it a name as S3 notification. Let's name it as S3 notification because we are going to add the object in S3 and that's how we are going to respond. And now here we can choose here we can give the function a name as S3 notification. Then we can choose the entire runtime environment. For example, we have a program code already written in Python, in Node.js, in Java. We can choose the entire runtime environment. Let's say we choose Node.js for now, as we have the application code on top of Node.js. And then we can click on create function here. Once we are done, we can click on create function. So as you can see, this entire function is currently created. Now we can scroll down, we can choose the entire runtime. Even after choosing runtime beforehand, we can also change the runtime at any point of time. For example, we have a complete function package in Java, then we can choose Java 11, and then we can upload the function package. If we want to write the code in Python, we can write the entire Lambda function in Python itself. If we want to run the code for Node.js, we can define the code in Node.js as well, right? And in here, we have to create the function here. So we already have a function pre-configured here that we can use. Now, currently we have an application code on top of Lambda. So here we can choose the region in which we want to start working on. For example, currently we have defined AP South Pan. Currently we are in North Virginia, correct? So obviously we have to change the region in which we are creating the function. So first of all, if we are in North Virginia, we also have to change the region code. Now, North Virginia is US-East 1. So we have to make sure that the region is correct, because again, if we have a different region selected and we are deploying the function in some other region, then that will create issues. Correct. So here we have to make sure that these both remain same. And then here we have to add, now here we have the entire function created, so that now this function will be sending out an email. Just a moment. So this function is going to send out an email having now here where we can define the entire body, as in the message body. Here we can define the subject, whatever we need to define. And for sending the email, we have to enter the email address that we have verified using any of the service offered by AWS, namely SES. So here, let's say we want to send out an email, we can specify the email address. Let's say we want to send the email to us. We can, in source, we have to define the recipient's email address. The code here, now here we can define the to address. Let's say we enter our own address to receive this email. And now this is an email that we send as the to address, and here we have to enter the address of the recipient. Let's send it to ourselves as a part of our hands-on. Now, as a good practice, we should always be saving the code once we are done, and then we can click on save function. Remember, the entire code has to be correct, because even if there's a slight mistake in the entire code, the function is not going to be saved. Now, once we have the function created, then we can test the function as well. If you want to test it, we can choose the event template. We can create the entire event. Let's say same way we create the entire Selenium testing script. So here we can choose the entire event type, or we can choose any of the event template. For example, here we are testing for S3, S3 for put request. So here we have the entire testing template already available. If you want to use this one, then we can use it, or we can customize it exactly as per the requirement. Now, if you want to use it, we can click on create. We can name this as S3 test. Okay. If you want to run the test here, we can click on run test. If everything is correct, then we would be able to see the entire execution return as succeeded. And here we can see the memory used and the time required for running this entire test code here. It was almost 9 seconds. So now the entire code has been added and tested as well. So now we can use the same function to send us an email whenever we are going to add any S3 object. So let's go back to our S3 bucket. So first of all, we have to create the entire function here, what we have done. And now we are going to use this function for Lambda to get an email whenever any event is triggered for our S3 bucket, correct? So in services, now we can move back to S3 as simple storage service. And here we can click, now here we have to choose the bucket which has been deployed in the same region as in which we have the function deployed. So we did create the function in North Virginia. So we have to choose a bucket available in North Virginia. So let's say here we can choose this bucket. We can see the bucket being deployed, and now we want to get notified for any object being added to this bucket. So first of all, we have to enable the event-based property. So we can scroll down, we can go to the properties tab, and then we can scroll down, and in events we can find the event properties. So currently we have one event already added, so let's delete that just to avoid confusion. And now to start from scratch, we can click on add notification, and here we have to choose the notification, that means the event type. First of all, there are multiple events supported that from which we can get notified. For example, we want to get notified on put event. So basically these are all actions. Put refers to whenever any object is added. So when we start discussing on multiple policies, we are going to discuss that part. So for every resource, we have multiple actions, like we have read actions, write actions, and put is an action available in the read operations for S3. That means whenever any object is being added, then that is referred as put actions. Or if we are trying to add anything, we want to get anything, then we have put object, get object, or different actions available. So if you want to get notified for every time we add any object, we can use put. Here we can add prefixes. For example, we have a folder by the name of images, and now we want to be notified whenever any object is added only to that folder, not to every other folder in the same bucket. Then we can be specific for that prefix itself. For example, we have some documents. We have a folder by the name of documents. Now we want to be notified whenever any particular object is added only to documents, not to the other folder. Then we can be specific. If we want to be specific that we want to be notified whenever any special extension files are added. For example, we want to be notified that whenever if we add .pdf documents, we add MP4 videos, we add the JSON log files, we add multiple HTML files. So whatever extension we want to be notified, we can choose it accordingly. And then we can choose the notification type as Lambda function. We can choose the function type as S3 and now click on save. As we can see, this event has been currently saved, and now we can start using this event. Now whatever Lambda function we have associated with it, we would be able to get notifications on top of it. Now for seeing this entire Lambda function implemented, we have to go ahead and add some objects. So let's scroll up. In overview for the bucket, let's add any object so that we can get notified. We can click on upload. So let's say we add any file here, we can choose any file. Let's add a simple key file, click on add. Next, we can keep the class the same, we can click on upload. And now one key file is currently being uploaded in the bucket. So as you can see, our key file has been currently uploaded. Now, if we come down to our email, we would be able to receive an email that has been sent to us from Lambda function. Can we all see this? Now we have the same function that we have created, email from Lambda, and an object has been added to S3. So the main agenda for today's session is we are going to discuss on the need for data pipeline. We are going to discuss on what exactly data pipeline is, what are the different components available in data pipeline, and how we can have the entire data pipeline deployed. So now let's get started. So first of all, let's discuss on the need of data pipeline. Now let's understand this by a hypothetical example. So for example, the main goal of any business currently on Pinterest, the main goal is to improve the business by targeting content, because Pinterest, as you know, is a really good content marketing platform where we can design, which is highly useful for creative professionals so that they can upload the designs, the patterns, and they can build a community, and then they can get the right target audience who are looking for that particular work they are currently doing. Now, in order to, we can have multiple goals here as well. Like we can have goal 2 where we can manage application efficiently, and then we can improve the business faster but at a cheaper rate. So these are main 3 goals that we are trying to achieve as the example, right? Now the problem statement here is, again, in terms of problem statement, we have now there's a huge amount of data stored in different formats as well. So pre-processing, storing, migrating the entire data becomes complex. especially when we are talking about unstructured data set. So when we talk about data set, then we have three types: structured, unstructured, and semi-structured. And majority of the data coming in from the social media platforms, they are highly structured, or in some scenarios semi-structured as well. And then here we want to, in terms of these social media platforms, we have to have a real-time data for registered user. We need web servers logs for potential users and demographic data for login credentials, along with sensor data and third-party data set. So there are different formats of these. Now these data are all available in different formats. And again, that's why the entire processing, taking the storage, the migration of data from one point to the other is also going to be complicated. It is not going to be an easy task. And because again, for real-time data for registered users, we can use a service called as DynamoDB. So DynamoDB is basically used for unstructured data set, where we can have schema-less data set stored, and then we can retrieve it, we can define the time to live, and again, we can retrieve the files at any point of time. We can easily do that. Then we have web server logs for maintaining logs, and that too in a cost-efficient service. We can use something called as S3, where S3 is a simple storage service offered by AWS for storing static data set. Then for demographic data and logging credentials, we can use a service called as Amazon RDS. RDS refers to Relational Database Service. And then we have S3, again for storing sensor data and third-party data set to maintain the balance between the cost and the pricing. So we have different solutions being offered for different problem statement that we have as a part of services offered by AWS. And again, here it is going to be a feasible solution. We can analyze the data and convert from unstructured to structured format. And the optimal solution would be to use a data pipeline, which handles processing, visualization, and migration of data from its own end. That's the main solution that we can offer for these different problem statements. The main problem statement from this entire scenario is the data migration itself. Suppose if we want to migrate data, we want to simply store data in multiple locations. For example, we want to store the DynamoDB in S3 here. We want to store data from our EBS columns into S3. Then we can easily do that. And that's why we have to take the help of service offered by AWS in the entire cluster of 150 plus services, that is data pipeline. So first of all, let's understand what exactly data pipeline is. So data pipeline is basically a web service that allows us to process and move data between different AWS computation and storage services, as well as on-premise data sources at specific intervals. So using data pipeline, we can define, if you suppose the EC2 instance that we have been working on, right? So now daily it can copy all the log files and store in the S3 bucket. And here we can define the weekly task. That means it should launch the complete data analysis, and that can be mapped and that can be processed back. We can step forward with Amazon EMR. EMR refers to Elastic MapReduce. So data pipeline, again, they are connected. They can be used with multiple data stores. Like we have RDS, DynamoDB, and then we have S3. So here we have RDS, DynamoDB, and S3. It can be used with multiple computation resources that you want to deploy. And again, we can have the entire data being stored as a part of data store itself. Now, as a first example, we can launch our data analysis where we can collect data from different data sources, and we can perform the EMR analysis and we can generate weekly reports if we have different data coming in from different sources from DynamoDB. Then we can connect them with the daily EMR analytics that we can perform. And then here if we have bulk data coming in from S3, it can also be processed by the EMR, and then we can combine multiple sources coming in into a complete MR, we can say EMR analytics, and then we can use on the server or storage services for storing all the log files for it, all the important log files one by one. Now, the main benefit of data pipeline Again, can be used to provide a drag and drop console where we don't have to manually select the file here, unlike all the other platforms. It is built on distributed, reliable infrastructure. That means even in any kind of failures, or we can say failovers, the main server has been structured in such a manner in different regions and zone. That means it will take the least amount of failovers, and in case if we face that, we can easily come back. Because again, for large applications, the downtime matters a lot, because again, if they are large applications and they observe us downtime of even few seconds, then that means that they are going to suffer a big loss. And then it supports scheduling and error handling. It simply distributes the work to one machine or many. It is inexpensive to use, and it offers control over computational requirements. All right, so now next is we have AWS data pipeline components. So pipeline basically has three main core components available. Like we have pipeline definition. So basically using pipeline, we can specify the business logic of data management. Then we have pipelines. So now we have in pipeline definition, we can define data nodes, activities, schedules, preconditions, resources, and actions. So basically, without every component, we cannot have a complete data management being done. So we have to define where exactly data is located as a part of data nodes, then the activities which has been scheduled on that particular data set, along with the timestamp, then what are actions that we have taken, for which all the resources this entire policy is going to reflect, or you can say affect, and then what are the preconditions required, if any. Then we have to define the entire pipeline where we can schedule, where we can use pipeline to run the task to perform defined activities. And here we have pipeline components, instances, and then we have attempts. That is which all pipeline components we are going to configure, how, or we can say how many or which all instance we are going to use for extraction, again the entire number of attempts. And then we have task runner. So again, it will simply allow the AWS data pipeline for tasks and then perform those tasks. So it can be pipeline scheduled tasks, and again it can be task runner for tasks. And then whenever the conditions are being fulfilled, then only the entire task is going to be deployed. And again, here when we are following AWS data pipeline for tasks, then we can perform these given tasks as a part of data pipeline, where we can define the entire scheduled task for pipeline. We can retire the remaining pipelines. We can, and again, if you're going to, first of all, if you're going to hold that up, we can simply use the task runner for the polling task. Then again, here, if the entire task has already been succeeded, then we can simply ask the returner to report back when the time is done. So that's how the entire component of data pipeline is structured. So now we are going to look at the hands-on on top of it. So now let's get started on our discussion on a service named as data pipeline that we basically use for seeing how we can migrate our data set from one service to the other. And for example, let's say we have a data stored in S3. Now we want to migrate it to from as a part of unstructured tables in DynamoDB. We have some data stored in DynamoDB, and now we want to migrate it to we can say to S3, or for example, from S3 to Redshift, Redshift back to S3 and to other services, then we can use a service called as data pipeline. So now let's see how we can get started. So let's move back to a console. So now in console, we have to look for a service named as data pipeline. So now just like we have been looking at multiple services, we have to look for a service named as data pipeline. So as we have been using the same search bar, we can search for data pipeline as a service. Let's open it up. Now, in case if we don't have any data pipeline deployed yet, we are going to see this blank screen. And remember, data pipeline is not available in every service as of now. So data pipeline is currently available only in 5 regions. And to see the list of regions, we can use the region link available on top. So here we have North Virginia, Oregon, Sydney, Tokyo, and Ireland. So we have Orient, and again we have only these available regions supported that we support data pipeline as of now. And still, these services which are not available currently, they are being deployed in multiple phases. Because first of all, for any new service, it is being tested in a selected region, and if it is successful, then only it gets deployed in multiple other regions as well, step by step, right? So here to get started, we can choose any of the given regions here. Let's say we start with North Virginia here. So here we have selected US North Virginia, so we can stay in North Virginia to start deployment of our service, and here we can click on get started now. And here we can see, here we can define the entire pipeline by defining the name. Let's say we can define the name as the pipeline for let's suppose for we are going to create for Educa for the month of May 2020. So basically we don't name it as a, we can say any general name. Here we simply keep it restricted to the type of job that we are going to create. So for example, if you're going to create a pipeline for S3 from S3 to DynamoDB now, we haven't discussed on these services, like what exactly is DynamoDB, what exactly we mean by Redshift, by MySQL tables. These are something that we are going to discuss in our further sessions, step by step. So first of all, here we can build using a complete template. Now, first of all, here we can define a description as well. Why we add a description? Same as every other service. If we are using the same, if multiple other people are also going to be using the same pipeline, then they should be aware of okay, what exactly this pipeline was created for. What's the main purpose for it, right? And that exactly is what data pipeline is useful for. So Suman, the data pipeline is basically used for migration of data from one service to the other. So in case you don't want to migrate them one by one manually, then we can use data pipeline for migration. Let's suppose if you want to migrate from any table in DynamoDB and save it to S3 or vice versa, we can easily do that using data pipeline. All right. And again a reminder that again this is not a part of the again if you are going for the task certification point of view, then this is not a part of certification till associate level. But again, and this comes as a part of discussion when we are going for a professional level training, but not till associate level of certification. But in case we are going for any enterprise solution, we should be well aware of how things are being deployed in the enterprises by using this service, right? So here we can define the type. So here we can choose a source as a build type, where we can choose from if you want to get done a simple CLI command to create a complete template from scratch. So in case we are familiar with the entire CLI, as in the shell scripting, that we can go ahead and use a CLI for creating the entire data set, or we can export if we have a requirement or working with DynamoDB. So DynamoDB, now we haven't discussed on DynamoDB yet. So DynamoDB is basically a NoSQL service offered by AWS, which is useful for transferring, which is useful for unstructured data set. So here we can define the entire data set in terms of rows, where we can have a faster access to data set as compared to our traditional database. We can have a complete schema-less structure, and then we can deploy, the entire DynamoDB, we can say unstructured data set as a part of table here. So here we can choose from if we have any backup. Now once we suppose that today we did export our DynamoDB table to S3, and after a while, for example, suppose after 1 week, after 3 weeks, now we want to restore that table from the data that we have exported. Then we can choose import DynamoDB backup data from S3. Because again, after exporting, because when we are exporting it, we are mostly storing it as a backup only. So that for any point of time, we can use it for, if you want to share that backup with any other account owners, we can easily do that, because then we are going to get a complete S3, or you can say shareable link using S3, like we discussed. So we can either use that link, or we can use the DynamoDB backup to restore or create any new table at any given point of time. We can choose any of these different DynamoDB templates. If we have a requirement of using EMR, so EMR is again not a part of discussion for the associate level certification, but EMR is basically Elastic MapReduce. Just like we have MapReduce components for big data, we have Elastic MapReduce, where we can use MapReduce cluster, and we can run a job on MapReduce cluster itself. We can easily do that.
And then we can also choose how we can run the job for RDS. RDS as in Relational Database Service. Again, this is a service that we haven't discussed so far. But again, if you want, RDS is basically a relational database service that is offered by AWS. That is something that we are going to discuss in our next module itself. And RDS is basically used for designing the entire databases. For example, here we can choose from multiple database engines offered. Let's say if we can choose from MariaDB, we can choose from Postgre or Aurora or MySQL instances. We can choose Oracle database engines. We can choose Microsoft SQL servers. So depending upon our requirement, we can choose any of the given database engines, and then we can copy the full RDS MySQL table to S3, or same way we can do vice versa. That means we can import the copy from S3 into MariaDB into RDS as well, or we can copy the incremental copy, just like we had discussed the concept of incremental incremental backups. So incremental backups, just like we have incremental backups in S3, right? Same way we have incremental backups available in RDS as well. So for every subsequent changes, the same backup will be stored and updated, just like we had discussed earlier. And then we have load S3 data into into RDS MySQL table. So if we have a local file, for example, if we have a local SQL import available in S3 bucket, then we can use that table in order to restore the RDS that we have launched. We can use any of the given RDS instances. And then towards the end, we can copy the full RDS SQL into Redshift. So Redshift is basically, again, a service that we are going to discuss further on as a part of our entire segregation training. So Redshift is basically a data warehousing service that is basically used for storing data. If we have data coming in from multiple sources, let's say if we have data coming in from multiple, suppose 5 different sources. Let's say we are trying to perform the analysis of sales data for Walmart. Then we can store data set coming in from multiple sources, and that too in a centralized location. And then we can connect that data warehouse to multiple platforms. I suppose if we want to connect that with machine learning platforms, with multiple BI tools like we have Tableau, we can connect that with ClickSense, we can with Alteryx, with Informatica. So we have multiple integrations available that we can connect to as a part of data warehousing service. And similarly, if you want to copy the RDS MySQL table to Redshift, if you want to go for incremental copy, incremental same as incremental backups, if you want to store incremental copy of RDS MySQL table into Redshift, if you want to load data from S3 into Redshift, then we can choose any of these services accordingly as per the requirement. So we can choose any of the given template. For example, suppose if you want to export any DynamoDB table, so we can choose export DynamoDB table here, and then we can choose. Now, for example, suppose if you want to ship any incremental copy here, correct? For example, here we want to maintain an incremental copy here for RDS. So as we can see here in RDS, we can choose the entire column name. We can choose the MySQL credential that we have generated for our entire account. We can choose the entire output folder, output S3 folder as in the bucket name, right? Suppose if we have a specific bucket we can choose from, for browsing, we can choose the entire S3 buckets. Now here we can see the list of all the available buckets that we have, right? For example, let's say if we want to use this one, April 26. And again, if we have any specific folders, we can see we have folders for, let's say we have folders for financial reports. We can choose any of the given folder, click on select. So here we can see the entire folder has been selected. That means if we enter the credentials for the RDS instance that we have deployed, we can choose the output S3 folder, and then we can deploy the solution accordingly. And then we have to define the MySQL username. That means the database username here. We have to choose the instance type from which we are going to use for the migration. Then we are going to specify the instance ID. Instance ID as in every service in RDS is also coupled with multiple RDS, we can say instance. So for support, just like we deploy EC2 instance, we also have to deploy RDS instance, and then we can choose that instance in order to migrate the data here in S3. All right. So basically here we can migrate the entire schema, the entire database here. And then once we specified that, then we can define the entire schedule as well. That means when exactly we want the entire migration to be happening. So we can define, if we want to keep it manual, that means we don't want to automate, we don't want to define a complete schedule. Then we can define, okay, we want this to be integrated on a pipeline activation. That means if we go ahead and manually activate that, then only this entire migration will take place, not on a regular basis. And then we, again, if you want to keep it on a schedule, because generally we keep it on schedule itself, then we can define, we have to run this entire migration every 1 week, and that too at a specific timeline. So we can keep the entire window open so that we can have the entire migration executed in that particular time frame itself. And then if you want to maintain logs for each and every activity here, we can enable or disable logs. So logs are something that we can also maintain by using another service that we are going to discuss as a part of our certification training, that is called as CloudTrail. So CloudTrail is basically a fully managed database, or we can say log management service, through which we can maintain the log activity. That means the activities happening for the entire AWS account from any user, from any region, and for every read and write operations happening for every service. We can also use the entire location for maintaining the log record as well that has been generated from this particular pipeline. For example, if you want to maintain the log records for the entire operations team, to know in case there has been some failures, then we can use these logs for the references, or if you want to refer to any other logs, then we can also do that by using the entire log that will be saved in the given folder that we can specify here. We can easily maintain that. And then we can define the security access. That is, again, if you want to be specific for any particular roles. Roles, as we had discussed, it simply gives the access to power one service to the other. If we are going to create a complete schedule for letting the RDS write a role, we can say some data in S3, then obviously we had discussed that we need to make sure that the RDS roles are also defined. That means we have to make sure we have a role defined, giving the access to the RDS to write data on top of S3, because if we don't do that, this is not going to generate, or you can say write anything on S3, as we had discussed. So for one service to communicate with the other services, we have to make sure that we are given the right set of credentials. And roles will simply allow us to do that. So if we keep it default, again, it can simply create our own role and then have it deployed here. And then we can use tags. Tags, as we have been discussing, tags are one of the most important component for any application that we are going to deploy. So we can maintain the company, so we can maintain the resource as a part of the entire application, so that we can choose that particular app. We can, for example, if we had deployed 50 different resources for an application, including this entire data pipeline, then we can see the entire list of all the resources at once. We can see the entire billing as well, and we can have a complete control over our solution when we are combining them by the concept of tags.
So we'll be starting off with the first service, which is CloudFormation. So CloudFormation is a great automation tool that helps you provision resources via using JSON or YAML scripts. So essentially you supply the script to the CloudFormation service, and CloudFormation service would provision all the resources that you have specified in the script. So it helps you treat infrastructure as a code, wherein now that you're treating your infrastructure as a code, you can have repeatable architectures on the fly. So services like CloudFormation are very widely used to build your DR environments on the fly, subject to RTOs and RPOs, what your company has committed to your internal and external clients. Then we'll be talking of various options or services available within OpsWorks services. So again, the principal use case is for services like OpsWorks, that they help you to manage the configuration state of your entire application. So imagine you have thousands of servers running, so managing the configuration state of your application can quite be challenging. So tools like Chef Automate, Stack, and Puppet Enterprises, these tools actually help you to manage the configuration state. And in addition to that, they also help you to manage the entire life cycle, wherein these tools help you to right from the provisioning to managing deployment of code, managing configuration state. So they help you manage the entire life cycle. The first service that we'll be talking about is CloudFormation. And CloudFormation is kind of mother of all automation services within AWS. And that helps you essentially to manage various infrastructure components that your application uses in the background. So it is very good for wherever you need repeatable environments. So I've seen a lot of organizations, they actually build scripts to provision environments on the fly. So for example, UAT environments where only the customer has the access to. So you don't need it for full-time basis. So you can build these kind of environments repeatedly in a similar fashion, and you can provision them in a couple of minutes as we'll see. So it's a service that helps you model and set up your resources so that we can spend less time managing those resources and rather use more time focusing on your applications that run in AWS. So essentially, we'll be creating templates that describe all the resources that you would want to provision, like EC2 instances, RDS instances, your VPC, and CloudFormation would take care of provisioning and configuring those resources. So in that, if you're using a service like CloudFormation, you really need not create resources on individual basis and configure them. And the service is smart enough to figure out the dependencies as well. So essentially helps you treat infrastructure as a code and can provision all the services that we have spoken about on the basis of a CloudFormation template, which is essentially a JSON or a YAML document. So helps you quickly replicate your infrastructure, easily control and track changes to your infrastructure. So essentially it will build a stack for you, which is the outcome of the template that you supply to the CloudFormation service. So as I said, it helps in automating and simplifying the task of repeatedly and predictable creating group of related resources that are part of your application. So there are three components to it. The first one is the template itself, which could be a JSON or YAML formatted file. So JSON and YAML, they are open standard formats and pretty easy to write. So Amazon maintains a pretty good number of sample architectures on their portal. So you can always, most of the time, you can always find pre-baked templates. Then the output, as I said, a stack, which is grouping of resources that you have specified in the template. And you can apply updates to the stack. So let's say you opted in for a specific instance type and now you want to upgrade it. Using CloudFormation, you can apply changes to the stack. Also, the service is smart enough, can detect errors wherein, let's say, the CloudFormation service due to an error in the script was not able to provision a RDS service. But already the service has provisioned the underlying VPC, various other EC2 instances, load balancers, auto scaling group. So service detects that the template is failing at a point. So the default action is rollback. So what it will do is it would deprovision all those resources that it has provisioned. So it will give you an error. So you can fix that error and then run the template again. Then the resources that you get based on what you have specified, they'll be in the desired operational state, and collectively you can manage all those resources as a group. So templates is the key thing, wherein based on what you have specified in the template and supplied it to the CloudFormation service, the service will provision those resources. So major elements of your CloudFormation template would be format, version, description, parameters, metadata, mappings, conditions, resources, transform, and output. So out of these, only resources is the mandatory section that you need to specify within the template, because CloudFormation has to know what resources you are trying to provision. Rest all are optional. Description, again, what the script is all about. Parameters is a way wherein you want the user to enter inputs during the execution of that particular script. So let's say we're giving the user who's running the script a choice that during the runtime of that template, you want to ask the user to specify a specific instance type. So we're giving him an option to specify which instance he wants to provision. So it could be T2 micro or any other instance type for that matter. Then you can specify what SSH locations that you want to allow. So again, any input that you need from the user, you would be specifying it in the parameters section. Then you have mapping section, wherein you map, it's kind of a lookup table that you can define within the script itself. And then there's the output section. So within your script, if you want the CloudFormation to publish specific outputs, such as, let's say, EC2 instance public address that is associated with it, so you'll have to explicitly publish that. So resources is the only mandatory element that you need to specify within the CloudFormation template. So description, again, what the script is about, the resources that what you would be provisioning, and then output is again a set of values to be made visible after CloudFormation has finished executing the script. So let me show you a sample template. So this is a sample template wherein the first part is the parameters part, wherein we're looking at the user to supply some information. So you can specify what type of information you are expecting, whether it's a number or a string. And the default value that what we have said is M1 small. So if user does not specify which instance type to select, the default will be selected. And we are forcing these allowed values. So user has option only to select from these instance types. Then there's a mapping section. So in this case, we are specifying for a specific instance type, whether we want in terms of virtualization, whether we want to use para-virtualized or HVMs. Then again, the second mapping that what we are doing is depending upon the region. So if the region is, let's say US East 1, the AMI ID that you want to pick up, you will have to specify the AMI IDs. So depending upon which region you are executing, a specific AMI has to be picked up. EC2 is a region specific service, so you will have to explicitly specify the AMI. Then, as I said, resources is the mandatory parameter that you have to specify. So in this case, we are saying that we are looking out for a EC2 instance, and within the resources, what we are doing is we are configuring it and installing PHP onto it. And to look at the image ID, I'm trying to capture the details based on the parameter that was specified. So I'm using finding map and looking out for the region and the AMI ID. Then I'm configuring the security groups here, wherein I'm enabling HTTP access for this particular instance. And then lastly, in the output section, I explicitly want what is the DNS name that has been assigned to the instance in question. So what you see on the screen is very similar to what we saw in the template. So pretty self-explanatory. Resources is the one wherein we're not using mappings out here. We are simply indicating image IDs, whatever the image ID is referred to, instance type, and the reference to key pair. So key pair in the parameters, we are asking the user which key pair he would like to use. And then in the output section, you are just simply printing the instance ID that is associated with the instance that the service creates for you. So stack is the resultant output that you get when you execute your templates with the CloudFormation. So it is a collection of resources. So these resources can be created, deleted, or updated in a stack. And additionally, you could have nested stacks as well. Let's say you're using one template just to provision your underlying infrastructure components, another template or stack to manage your application on top of the resultant stack that you have created. You could have nested as well, wherein output of one stack can be passed on to other stacks as well. So we'll go to the CloudFormation dashboard. So make sure that you are in the right region in which you want to provision your resources. So we have a lot of sample templates that you can play around with. I'll be just simply uploading the template that I have. So let's say I'm creating this stack as UAT environment. In the parameters section, we had the default value that was supplied was M1 small, but we're still giving the user an option. He can actually go ahead and change it. So now if I change the value T2 micro, so this would be passed on as a parameter to the CloudFormation service. So you can set up rollback triggers, wherein this would allow the CloudFormation service to monitor the state of your application during creation and an update. So by default behavior is to roll back. So events tab is the one that you would like to refer, which indicates the steps that the CloudFormation service is performing. So it has already created security groups. It has started the process of initiating the EC2 instance. So any resources that it would have completed, you'll see them out here in the resources tab. Then you have output section. So this would be published at the end when the CloudFormation has finished the provisioning of all the resources, and based on what we had specified to be published, it would be published out here. So we do see that the service has provisioned a EC2 instance along with the security group, and in the configuration steps, it will get the instance to the desired operational state. So it's create complete, so which indicates that the service has been able to provision all the resources. So in this case, it was a single EC2 instance. Now, if you look at the Outlooks tab, we had explicitly published the DNS name of the instance. Also, if I want to update this stack, so let's say I want to change the instance type. So let's say T2 small. So in the background, what it does is it actually compares both the templates, one which was run for the first time and the one that we are supplying right now. So it will look out for the changes, and we can very clearly see resource type that needs to be modified is EC2 instance. So it will actually go ahead and terminate this resource and then provision a new one for us. So now we do see that the instance type has changed from T2 micro to T2 small. Also note that since now we are managing the resources as groups under stacks, so all the resources that the CloudFormation service provisions, they're tied to the life cycle of the stack. So if I delete the stack, all the resources that it would have provisioned would get deleted. Okay, so meanwhile, the CloudFormation deletes the entire stack. So again, we are allowing the user to select the instance type, but this time we are going ahead, wherein we are asking the user to make the association with the keys SSH location. Then mappings we have already seen. We're setting up an NAT instance in addition to various other VPC components as well. So in the resources, you see that we are specifying VPC. So it will create a VPC for us. It will create subnets for us. It will provision internet gateways, attach internet gateways, make changes to the route table, subnet associations, NACLs. So essentially, we spend about more than 2 hours in understanding VPC and how to deploy it. So now with the help of simple script, I can provision the entire underlying network and other application components in a couple of minutes. So in this case, the Elastic IP address is being used. So again, it is up to us whether we want to use the defaults or we want to change them. So we'll run this script and we'll see what is the output that what we get. Selecting the instance type, it will fetch all the keys available in this region, and SSH location, you can explicitly specify which locations you want to allow. So I'll keep it open at this point of time. So it has already created a VPC for us, defined internet gateway, made the associations of IGW to your specific VPC. So this is the VPC in question that it has created for us. Then multiple subnetworks. You have internet gateway which is attached to it now and still not reached the state where it has assigned a Elastic IP address to it. So it has already started the provisioning of the EC2 instance. Once the instance is available, it would be associated with the Elastic IP address. So we do see that the service has allocated a Elastic IP address and that would be assigned to our instance in question. So the create is complete now, and under the output section, we have the desired output. So right from creation of the underlying network, which is the VPC, and configuring various other components. So under a couple of minutes, we have been able to provision almost every resource that we had wanted to provision for our application stacks. So a great tool for having repeatable environments wherein you want to manage resources in groups. And I personally used it for building DR environments. We saw that you can build the entire environments in, depending upon the scale and size, in less than 10 minutes or so. So you can use this tool for a variety of purposes. So moving on, we'll be talking about various service offerings within AWS OpsWork. So now we had an introduction on CloudFormation, which is template driven provisioning. So if you look at this illustration, scale of control and convenience, again, CloudFormation is a great tool, but again, you need to have those scripting skills to build complex scripts. So if the environment is large, so managing at the script level can get complex beyond a point. So on the extreme right, which is you have the complete control where you implement the resources on do-it-yourself basis, create individual resources, manage their configurations. So this is where you have the maximum control. But if you want to move on more towards the convenience scale, you have other services starting off with the CloudFormation, which again is more of a do-it-yourself model. Then moving on further, you have another two options available within AWS. The first one is AWS OpsWork. There are three services that are supported within OpsWork. One is Chef, the second one is Puppet, and third one is OpsWork Stack, which is again implementation of Chef. So these tools allow you to better visual representation, gives you a service layer where you can provision your resources in much more better visual representation. Additionally, they allow you to manage the configuration state of your stacks. So as I said earlier, let's say you have 1,000 servers. You want to make a simple change to a properties file. How do you do it? So with tools like this, you can always achieve that. And then lastly, you have Elastic Beanstalk. So this is a service from Amazon directly, whereas it is well suited for organizations or typically targeted at developers who want to provision resources on the fly. Very easy to use with. So wherever you want to give complete control of resources to your developers so they can spin up environments on the fly, terminate them when you don't need them. So this is where you would be using Beanstalk. So now with respect to managing your applications reliability and scalability, they are very important. And there are a lot of underlying operational tasks that need to be taken care of, right from provisioning, deployment, configuration, monitoring, security, scaling up. So as your application grows, these operational tasks can become more time consuming and error prone, and you would not like to trade off control or flexibility for ease of use. So any resource that the service provisions for you, you will still like to access that resource. So some tools actually don't allow that, but services available within OpsWork, they allow you to have complete control over those services. Let's specify what configuration management is. It is in practice a code that is used to define and maintain the state of both your new and existing resources throughout their entire life cycle, as we saw right from provisioning, managing, maintaining. So when you provision your compute resources, again, you have a series of activities to perform at the operating system or at the host level. Then configuring your application with respect to their specific configuration, their dependencies, and then ongoing maintenance could include new version installs, package updates, new configuration, new deployments, etc. So the need for services like OpsWork, as we have said, helps you manage the entire life cycle of your application. And with the help of OpsWork tools, depending on what we are choosing for, we can manage. So it's pretty easy to use, secure, very powerful because you have automated everything. So chances of manual error are very less. So overall, it increases your efficiencies and that results in enhanced productivity. So OpsWork essentially is a configuration management service that provides managed services of Chef and Puppet. Both Chef and Puppet are automation platforms that allow us to use code to automate the configuration of our servers. And OpsWork let us use Chef and Puppet to automate how services are configured, deployed, and managed across your EC2 instances or your on-prem compute environment. OpsWork gives you three solutions to configure your infrastructure. So when they had started off, with Opsworks Stacks only, which is implementation of open source automation tool called Chef. Now you have offerings available for Opswork for Chef Automate, and another very widely used tool is Puppet Enterprise. So as we saw on the console, we have three offerings: Opswork for Chef Automate, Opswork for Puppet Enterprise, and Opswork Stack. So Chef Automate, it's again a fully managed configuration management service that hosts Chef Automate, which is a suite of automation tools from Chef for configuration management, compliance and security, and continuous deployment. So a lot of applications that you see, they're built on the basic premise that your releases would be done almost on real-time basis and support the concept of continuous integration and deployment. So Opsworks, a service layer that they have built on top of Chef server, and the service would automatically patch, update, and back up your Chef server. So Opswork would eliminate the need to operate your own configuration management system or worry about it, maintaining its infrastructure. So it will give you access to all the Chef Automate features such as configuration and compliance management, which you can manage through Chef console or command line tools like Knife. And it works pretty good with the existing Chef cookbooks. So you'll opt for Chef Automate if you are an existing Chef user. So Chef Automate is compatible with cookbooks and recipes. So supermarket cookbooks here refer to the community support or the community forums wherein you can find a lot of cookbooks and recipes. So recipes essentially, that is the piece of code that you want to execute, and cookbooks are repositories for your recipes. So with a single tool like Chef, you can manage your servers. They could be within the cloud, they could be outside cloud. So with a solution like Chef, you can manage an entire distributed workloads using a single tool. So if you already are running a tool like Chef or Puppet in your organization, so my recommendation would be to extend that to cloud rather than opting in. If you don't have, then you can definitely look at Opswork for that. So cookbooks, we have already defined that they are essentially the containers for Chef recipes. So recipes, they are synonymous to specific piece of code that you want to be executed at a given point of time. Cookbooks would also contain, in addition to recipes, additional files, libraries, or dependencies to configure your environments. So recipes in Chef, they are written in Ruby language, and essentially you'll have piece of code written in those recipes. So that piece of code could mean install and configure software components, deploy application, call in other recipes. Then very recently introduced support for Puppet Enterprise. So again, it's a fully managed configuration management service that hosts Puppet Enterprise, and the suite includes a set of automation tools from Puppet for infrastructure and application management. Opswork also maintains your Puppet master server by automatically patching, updating, and backing up of your servers. And Opswork, like in the case of Chef Automate, eliminates the need to operate your own configuration management systems or worry about underlying infrastructure. So Opswork would also give you access to all the underlying Puppet Enterprise features, which you can manage through Puppet console. And it works seamlessly with your existing Puppet code. So you can choose Opswork for Puppet if you are an existing Puppet user. So this is again based on client server architecture where you have a designated master. All the nodes, they run a Puppet agent, and you have specific configurations or roles defined in at the Puppet server. These nodes poll the Puppet server on periodic basis. So if you want to push some changes, make the changes on the Puppet server, and these nodes would pull those changes and apply those changes. So with the Opswork Stacks, it lets you manage your applications and servers on AWS and on-prem. So you can have a distributed kind of an environment where Opswork Stack can help you manage the entire workloads. So let's talk about various components of Opswork Stack. So the first component is the stack itself. So it is the topmost level entity within Opswork. And essentially, like we saw in CloudFormation, it would represent set of resources that you want to manage collectively. So a good example for stack would be, let's say you want to create a stack for dev environment or UAT environment, wherein various underlying components would only be applicable to that particular stack. The second component is layers. So each stack will have at the bare minimum one layer, and depending upon if your application is n tier, you will have n tier, rather n layers in your application. So to keep it simple, you would have a layer for load balancers, a layer for web servers, layers for app servers, and a layer for database. So the idea here is that for each and every layer, you will have different set of configurations that you may want to manage. So configurations would be managed at a specific layer. So any change that you want to push through, let's say web layer or your app layer, you can push those changes directly. And that would be applied to all the resources within that particular layer. The third component is the instances. So compute resources form the baseline for any application. So an instance could be of multiple types. In auto scaling, we had spoken about. So this is where AWS has performed a custom integration with Chef, wherein you can have 24/7 instances, and these instances would always be up and running and available to you. Then you have time-based instances. So this is specific to scheduling plan in auto scaling, wherein based on a schedule, ops work will increase, and then based on the schedule that you have specified, it will decrease. Then you have load-based instances, very similar to dynamic scaling plan, wherein based on the thresholds that you have specified, so let's say CPU utilization, it can spin up additional resources to handle additional spikes, and then it can revert back to normal state once the threshold that you have specified is met. Then you have apps, which is the fourth component. So it actually represents the code that you want to run on your specific layer of your application. So this would contain the information which is required to deploy the code. So you can set it up on automated basis or manual basis. So the first part of it is to create your stack. You can provision a sample stack in which AWS would manage the creation of the sample stack on its own, or else we'll start off with the Chef 11 stack, the sub networks or the availability zones, default operating system that you want for the operating system. So you have just created a stack by the name stage that represents the staging environment. And now we need to add layers to this specific stack. So I'll add a layer and I'll use a pre-built layer, which means any resources that would be added up to this layer will come as pre-configured. So in this case, I'm using a PHP app layer. So there's one limitation of OpsWorks stack here, that it does not create load balancers for you at this point of time. So if you want to use load balancers, you'll have to manually create them and use them within OpsWorks. So coming weeks or months, you'll see that you'll be able to create the load balancer directly from the service out here. So I've added the layer, and at each layer, we can have specific settings applied to resources that would become part of this layer. So you have add instance. So you want to add your resources or your compute resources to this particular layer. So I'll go ahead and add one instance. Then you can specify the instances, be it if they're already running, you want to make them part of the stack, or instances outside AWS. I'll start the instance. So before I do a start, let's take a look at the various settings that are available at each layer. You have instance shutdown in general settings. So usually you want to specify a timeout here, wherein let's say you want to export log files from the instance when the instance is about to be shut or terminated. Then you have auto healing enable. So in case your instance fails, OpsWorks would take care of it. So the most important aspect is recipes. So recipes, we know they are the piece of code that we want to be executed to a resource that is associated with a specific layer. So since we picked up rebuilt layer, which is PHP, we do see 5 events out here: setup, configure, deploy, undeploy, and shutdown. At these events, these recipes would be executed. So the setup event it occurs after the instance completes the booting process the first time, and it is used for initial installation of software and service. So if you take a look at the recipes attached, it is installing MySQL, any dependencies, associating storage, Ganglia client, which is the monitoring, and then PHP and Apache. So essentially, all the packages that you want to get installed during the instance once the instance has finished up booting process. So very similar to bootstrapping, that what we saw when we were provisioning the EC2 instances manually. Then you have a configure state. So this is to ensure that your configurations on the resources associated with your specific layers, they are consistent. Then you have deploy event. So this occurs when you execute or you want to deploy your code. Then you have an undeploy event as well. So wherein it's completely the reverse of deploy. So you want to uninstall the application. And lastly, you have shutdown, which let's say you're stopping or terminating. You want to capture some cleanup tasks. Most commonly used task is shipping out the logs from your instances. Then you have network. So we're not using ELB right now. We are using public IP addresses. Then with respect to storage, what is the type of storage that we would like to use? Then security. So Opswork as a service can manage security groups for you. Else you will have to create your own security groups and apply them. So we'll let Opswork manage the service for us. If you want to send the logs to CloudWatch logs, you'll have to push the logs to the CloudWatch service. So we added an instance to the PHP layer. So we'll go ahead and start it. It's in the booting status ad right now. When it transitions to setup, all the recipes associated with the setup event would be run. So we've spoken about stacks. We have spoken about layers, instances. We'll have to specify which type of instance. So by default, it is 24/7. If you want to set up time-based or load-based, you can do that. So rather than interacting with auto scaling service directly, you can set up the rules out here in the service itself. So if you go to the EC2 dashboard, we can always see that the service has already initiated the process of provisioning a instance for us. Actually, the instance type that what we have selected is low on capacity, so that's the reason it's taking time. So I've selected an instance which is eligible for free tier. So it has transitioned from booting to running setup. So very shortly, we'll see that the status changes to online. And then once the status is online, what we'll do is we'll go ahead and install our application. I'll specify the repo URL. So once the instance is in the online state, I'll go ahead and deploy the application on this particular layer. Okay, so the instance has transitioned to the online state, and now what we'll do is go ahead and deploy the application. So since we have only one instance, I'm deploying this to one instance only, else we do have an option to select the specific instances if you like. So the application has been deployed to the instance in question. Now I can go ahead and access the application. So tools like Opswork would definitely help you in managing your stacks as a group of components. And in the second part of the demo, what we'll do is I'll add a database layer to it. And the application that we'll be building is your thought sharing or kind of an application where all the data would be stored in your database layer. So I'll go to layers again. I'll add another layer. I'll select a database layer. I'll add an instance. I'll modify the app that we had created for our previous demo, specify the document root. I'll specify the data source as Opswork, and I'm using version 2. I'll go ahead and start the database instance. So meanwhile, I'll go to the stack properties. I'm using a custom chef book, passing the repo URL. So we'll let the instance come online. So meanwhile, what I'll do is for the PHP layer that we had created, I'll associate a custom recipe on the deploy event. So transition to running setup now, and very shortly it should be available. You can monitor your resources directly from the Opswork service plane, the resources that have been provisioned. Okay, so finally our database instance is online. And again, I'll add a custom recipe to the database layer. We had already made those changes to the app, so we'll go ahead and deploy it. So this time it indicates that it would be executing on both the instances. I'll trigger the deploy event. So it has executed the custom recipe for database master, and now it's in the process of deploying on the PHP layer. The deployment is complete, and I'm actually redeploying the application. I actually accidentally specified www instead of web, which is the default document route for your PHP application. So post the revised deployment, it's working now. So you can. So had our instance selection been right, we had chosen appropriate instance types, we would have been able to achieve this in much lesser time. Also, like in the case of CloudFormation, any resources that you create using a service offering, they are tied to the lifecycle of the stack. And once you delete the stack, the service would go ahead and terminate the resources for you. Okay, I guess then we can conclude the session for the day. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!